Okay, we're working on a new instruction video for our LS1, LS2, LS3, LS376, LS6, and LS7 swaps. And we're going to show you an LS7. We have an LS7 in this orange car here. And I'm going to show you what these things look like when they're put together. And we have one in process inside that's got an LS376. This is an LS7, pretty much chromed out, and this has a 6-speed transmission in it. The car that we're going to be building is going to have the 5-speed in it. You know, the Getrag 5-speed. It's a low mileage 88 car, and the car is not here yet, so we've got some work we can do to the engine before the car gets here. So we're going to start with that. Like I said, this is an LS7 with a 6-speed. Okay, and this is an LS376 that we're putting in for a guy out of Oregon. The engine's pretty much installed. Most everything's installed. We have the wiring harness in there and everything. But I'm just showing you what these things look like in process, if you will. The LS3 that we're putting in the upcoming car, it's still in the crate, so we're going to be showing you that here in a second. Before we get on with the instruction video, my previous instructions for these LS kits were on a CD, and it was a lot of pictures and Microsoft Word documents with notes and detailed pictures and instructions for doing the LS swaps. I'm including a copy of that CD with the DVD instructions, the DVD that these instructions will be on. And if you have any questions about detailed pictures or anything, there's going to be a gazillion of them on that CD, and you can look up the pictures of detail shots that would be similar to the detail shots in this video. If you don't see what you want to see, you can find a lot of pictures on that CD. This is a Lamborghini Miara that we're building for a fella. It'll have an LS376 in it, or an LS3 in it, and we got all the chassis pretty much done. We're just trying to do the body now. And here's our crate engine we're going to be putting in the car. This is an LS3. And this is how they come, packed into a crate, and we're taking this thing from the crate to the road. As I said, the car that we're putting the engine into isn't here yet, but there is quite a few things we can do to the engine to get ready for when the car gets here. And we're going to be covering that today. Okay, this is the LS3 still sitting on the pallet. We took the top of the crate off, just unbolts and lifts off. And first thing we're going to be doing is putting this up on an engine stand. We have, as you can tell, the intake manifold. The front of the engine's over here at this end, and the intake manifold, of course, points this way. If you've noticed on any of the other LS swaps, we turn the intake manifold around. Part of turning the intake manifold around is that the oil pressure sending boss on the intake manifold, which is this unit standing up here, it's when you turn the intake manifold around, that's in the way. So one of the modifications we have to do early on is to redo that boss. I'll show you a little video on the other car what it kind of looks like. And we also have to make a modification to the oil pan. Both of those require that the parts are heliarced, aluminum welded, if you will, back together, or it requires some welding. So we're going to do those first thing, and then we can take them out to get them welded, and because we don't do that welding here, and we'll take them out to get them welded, and we can work on other stuff on this engine by then. You see on this engine, the intake is in so that the throttle body is at the transmission end of the engine, And when you turn the intake manifold around, that oil pressure sending unit gets in the way. Right now it's right down in here at the end of my fingers. It's really hard to see, but as we do the other car, you're going to be able to see it. The oil pressure sending unit plug-in is right here. This is the oil pressure sending unit for the Fiero, for the gauge. We also have another sending unit, the original LSx V sending unit, that's like what's on the other engine there. That's also in there. We'll be showing you that as we go, but that's the reason we're going to be making modifications to oil pan and to the valley cover underneath the intake manifold. We'll be showing you that in a few minutes. Okay, we have the engine on the engine stand. We've taken off the water pump off the front of the engine. We'll be using a electric water pump. We've also taken off the intake manifold. You can see the oil pressure sending boss that's sticking up out of the valley cover. That's what we have to re-angle here on the valley cover. That has to change because when the intake manifold is put back on, the throttle body's at this end, and it interferes with this. So we have to cut this down and angle it coming out in this direction and get it welded back on. Of course, we've got the intake manifold off now. And we also have to make a modification to the oil pan. We haven't taken the oil pan off yet, but when we put a V8 on, or when we put the V8 in the Fiero, we don't have to relocate the oil filter, okay, but they have this unit here that bolts on the side of the block. When you take this off, there's two holes, and in some applications, which I haven't seen one yet, these two holes, one of them is out and one of them is in, oil out and oil in, going to an oil cooler. That's what the provision is for. We're not, you don't use I think the Corvette's probably the only thing to use an oil cooler in some cases. And so what this little V-shaped thing does here is the oil comes out one hole and it makes a U-turn, goes right back in the other hole. But this piece right here interferes with our starter mount to be able to get the starter close enough to the center line of the crankshaft to be able to engage the flywheel. So what we'll do is we'll take this off. We're going to drill a hole inside the pan. We'll show you that real closely, real carefully. And we're going to drill a hole inside the pan and then weld these two holes that come out here. We'll just weld those two closed so the oil will actually do the bypass thing, do the turnaround, if you will, inside the oil pan or through that one hole that we're putting in the oil pan. But we'll cover that in a little bit. Here's the stuff we've taken off the engine so far. We took off the flex plate. Notice this flex plate is set up. It's actually a Corvette flex plate because it has this for the shaft drive. It goes back to the back end for the rear mount transmission. And we've taken off the intake manifold with the injectors and everything still intact. Okay, we have the oil pan off the engine. And we're getting ready to make our modification to it. As I said before, that we took off this block that goes on the side here, and you can see there's two holes that come out, and what they do inside that block is just make a U-turn. So what we're going to do is we're going to make a U-turn inside the pan instead of outside the pan, because got to have that clearance right there for the starter. The gasket is held on with little tiny pop rivets, and for example, one was right here. We just take a drill bit and drill that out and then get the oil pan gasket off. We'll put a pop rivet or something back in that later. And then what we're going to be doing is we're going to be going down inside one of these holes and we're going to be drilling a cross hole in there. And then we'll be coming out here and welding these two holes closed. And what we're setting up to do is to do that right now, and we'll show you as we go. Okay, our goal here when we're modifying this hole is to drill a diagonal hole through here that goes down and intersects the boss here where the filter screws on. And so what we do is drill a hole in at an angle. And what we did was we drilled it with a small diameter drill, and then we opened it up with a rotary file like this, and you know, did real careful and made sure we intersected that other hole. A thing to note is that the gasket that goes on here has a rubber seal around here, so you don't want to side cut this hole, you know, to an angle here on the edge of the hole as you're drilling this. You don't want to hit down here on the edge of the hole, at least not very much. The gasket does give you a little bit of room. So you don't want the gasket leaking, and you don't want to catch that edge. You know, that's a big thing. And you want to make sure you're headed at the right angle. So now if we take a look up inside here, it's kind of hard to see, but you can see where our drill bit intersects the hole. Looking through here, you can see where our drill bit's going in, and you can see it over here on this side. And then when we rotate the pan even further over, you can see the drill bit coming down in through there. Now I've got a bunch of still photographs of this from when we had just still photos for instructions, and I'm going to put those still photographs right here in the video at this point to show you what it looks like with a flash. Now that we have the oil pan modified, the valley cover also has to be modified. And of course this stuff's going to be welded, so you got to get all the oil and all the plastic parts and everything disconnected from these two aluminum parts when you take them over to get them welded. They don't like welding stuff that has oil on it, so like that oil pan will have to be cleaned up. And this piece here is what we're modifying, but first thing we're going to do on the underside is take out all these O-rings and this plastic cover and all the other pieces that are not aluminum, so that when it gets welded, that stuff's not in the way. So we'll take all this stuff off, and then we're going to come over here and modify this boss, and I'll try to cover that one step at a time. Okay, we're fitting and working on this boss right here, and we got it cut down to a bit of an angle, and we have the other piece, the piece that we cut off of it. You know, you want to cut it off because the thread and everything in here is kind of unique to that sensor, so we cut the whole thing off and then we re-angle it, trying to get it right where we want it. And we think we still have a little bit more grinding to do, but this is where we do a little bit of fitting and stuff to make sure before we get it welded on. We'll make sure everything's going to clear. And like I said, we think we need to angle this just a little bit more yet. And then when we put the intake manifold on, we can set the intake manifold down on there. Make sure you get down on the bosses right here where the intake sets into. And then right up in here, see there's a little bit of plastic sticking down, the little rib sticking down from on the underside of the plastic intake. That's going to have to be ground back just a little bit. And then as we come around the other end, if there's anything here that needs to be ground down for clearance, we'll grind it. Almost looks like this is real close right in here on the plastic where it's touching up to the valley cover. And if that's touching in there, we'll just put a little bit of grind a little bit of that plastic off, and we'll be all set. But as we come back around here again, this little piece of aluminum, going to go back on there, but see that rib's got to come out of the way before we can do any more fitting to get this down on there. You'll notice that the hole that's down through the oil pressure sending unit is a small hole. The hole that the sensor screws into is larger, of course, and but that is just for an oil pressure sensor, so that's what the size hole they put in the bottom of that manifold or that valley cover. Check back with you in a few minutes. Okay, we're continuing to fit the intake manifold. And you'll see, if you look up underneath there real close, a couple of ribs right up in here. we just ground a little bit off those ribs just to give a little more clearance right to here. When the intake manifold's tightened down, make sure we have plenty of room. And then over here on the oil sensor, we've got this thing pretty much located where we want it, and we've marked, see the felt marker mark on the intake manifold or on the valley cover to try to determine exactly what direction we're pointed, so that when we take it over to welder we can get it right. And if you can see up around in there, there's clearance all the way around this piece. Give you, you know, 1/8 of an inch clearance all the way around is good enough. We got more than that now. And when he welds this up, we're going to be careful to tell him to leave room for this, you know, not to weld out too far with his gusset, so that we have room for this screw to go back in. And you see, this is basically what we're going to have him weld right here, what you see. As long as it clears your intake manifold, you're good. And you got to screw some fittings into here, but for the most part, the oil pressure sending unit that came out of there, the fittings you're going to screw in aren't any bigger than that. Okay, I just got this stuff back from welding, and we welded these 2 holes closed. Now we're going to grind these flush, make this pretty, but there's a little bit of a bulge on each one of these welds. And we also welded the oil pressure sender blowing onto the valley cover. We'll show you these pieces again before we put them on after we ground them. Here we go. We ground the weld down, make it look pretty, although you can barely see this when it's all put together. When you get this welded, you want to try to keep them from welding too close to this hole right through here, because the bolt that goes in there has a built-in washer on the head of the bolt. You want to have enough room to clear that. But other than that, this is the general idea: is to get her ground down so it looks pretty decent and get it welded, and make sure you got it going the right angle. So we're going to put the oil pan and this valley cover back on the car, or on the engine, and get back to our build. All right, we have the oil pan back on. You can see that we ground the welds down a little bit here, and then you'll notice that we put a little bit of bevel right along this edge here. We actually did that before we put the pan back on. That's going to be for a little bit of clearance on the starter. The starter's real close to here. The problem with this swap is that you have to use a 163 tooth ring gear on the flywheel for the flywheel to come out far enough that you can engage it with a pinion from a starter. And so you got to get the starter in as close to the center line of the crankshaft as you can, and this is the place where you got to do it to be able to get it in that close. And the starter will be mounted right up in here, so you can still use the stock oil filter. But anyway, this is, we put a little bit of a bevel on here. See, this line here, right where my thumb is, used to go straight up, and we beveled it a little bit in towards the engine for a little bit more clearance. And we've got the intake manifold, well, we got the valley cover and intake manifold back on. We already discussed the fact we're turning the intake manifold around so that the throttle body is pointed out the other direction, gives more room for a cold air intake and all that. We also turned the fuel rails around. Once we got the intake manifold back on here going the right direction, which is with the throttle body at the same engine end as the flywheel, then we picked up the fuel rails up off here and turned them around so that this is still pointed up towards the passenger compartment. It makes it easier for your fuel lines. Otherwise, it would be pointed back towards the back end, and you got to route the lines around. And then down in here, we have the oil filter, or the oil pressure sending unit fitting. You can see that it's making clearance to stick it out at an angle. You don't have a lot of choices. It's going to have to come out right towards us here. And then this adapter fitting will go in here. I can't turn it here. Rob's going to stick it in because I can't turn it with my wrist turned backwards. There you go. And then we're going to put a nipple on here and then an adapter so that you can use both the oil pressure sending unit for the LS series engine and the oil pressure sending unit for the Fiero. That way you can operate your stock gauges normally, and the oil pressure sending unit from the ECM that works with the LS engine will still control your fuel pump then. We'll show you more of that later. Okay, here we are. We have the LS3, the top half of the LS3 crate, and we're using that for our little display table. These are the pieces we're about to put on the engine. The engine transmission adapter plate. This piece is unique to the LS engines. It only works with LS engines, and you have to use it with the LS1, LS2, LS3, LS376, LS6, and LS7 engines. This is the transmission side of the adapter plate, and this would be the engine side. We'll show you more of this as we put it together. We have the starter mounting block. It's called a starter mounting block, but it's a lot more than a block. This is machined this way so that we can get it up as close to the center line of the crankshaft as possible without modifying the engine block. That was the challenge with the LS engines. Here's the flywheel we're going to be using. It's a 163 tooth ring gear. It's aluminum with a steel insert. I have these custom made, and it's a custom design for this conversion only, for this type of swap only, for the LS engines. This will work on all the LS engines. Like I said, it weighs about 14 pounds. And it's aluminum with a steel insert, steel friction surface. The clutch we're using is a spec clutch that I have made for the LS swaps. This is specifically for LS swap using stock Fiero transmission. This car is going to have the Getrag 5-speed, and this is specific for that only. If we're doing a 6-speed swap, we have a different clutch that's also made by spec, but it's not the same configuration as this clutch. When we bolt the flywheel on, we use these GM flywheel bolts, part number 11569956. They come 10 to a package. That's so they sell an extra 4 every time somebody wants to put one of these together. And we'll start putting these pieces together and talk about more as we put them onto the engine. One of the reasons we had to design a new V8 kit for the LS engine specifically was because this is called a Y-block engine. Y-block engine is when on a normal small block Chevy, the oil pan or the bottom of the engine block is even with the center line of the crankshaft. On a Y-block engine, the casting of the block of the engine goes down past the center line of the crankshaft. Whenever you have a Y-block engine, Buick Grand National is another one, and then there's the old Ford Y-blocks, the 272, 292, 312 engines were Y-block. There's probably a lot of others too, but there's the ones I'm familiar with. And the reason we had to do the complicated starter mounting block and the larger ring gear on the flywheel, on a small block Chevy, we use a 152 tooth ring gear. The reason we had to use a larger ring gear was because the engine, being a Y-block, has skirting of the engine that goes down below the center line of the crankshaft, so it's hard to get a starter gear drive in close enough to the center line of the crankshaft to engage the ring gear. And in this case, to clear this, because this block is wider through here, and it got skirting coming down, we had to use the larger ring gear, because as close as we can get to we're grabbing the starter mounting block, and as close as we can get to the crankshaft center line is in this neighborhood right here. Is in this neighborhood right here, and the center line from this hole to the center line of the crankshaft requires that we have to use a 163 tooth ring gear. We'll show you that as we put the flywheel on, but I thought I'd make that note before we put the flywheel on so you can see the difference. Okay, we have the flywheel on and it's bolted on, torqued to 60 foot-pounds, and as you can see, the ring gear has to come out quite a bit for the go ahead, put that up there, for the center line or for the starter drive gear to meet up with the ring gear. You'll see that this piece here, especially once we started getting this all together, this piece here is as close to the engine block as it possibly can. What we end up doing, just to get a little bit closer, is just grind just a little bit of aluminum off the corner right here. That allows that piece to get up a little bit closer. And when you're looking at, you see these thin walls right through here and right up here at the top. These thin walls are that thin just because that's all the clearance we have around there. We'll show you that when we get it on the engine. Okay, here you see the adapter plates bolted on, and you'll notice that the ring gear, the black area right here, goes up behind the adapter plate. There was if you recall when we looked at the adapter plate, there's a step in the adapter plate, a counter radius on the inside of the adapter plate, and that's where the ring gear actually runs, inside the adapter plate. You look up here, you can see the notch that's formed by the counter radius on the inside. And the 5 bolts that are in the adapter plate right now, these are the bolts that are going to hold the transmission on. When you're putting the bolts in for the transmission, you'll notice that 3 of them, this one, and this one, all of them are close enough to the center line of the crankshaft that they're actually closer to the center line of the crankshaft than the outside edge of the ring gear. So when you put these bolts in to the adapter plate and tighten up their transmission, you have to be careful that the bolt doesn't bottom out on this lip that's on the flywheel. You want to make sure that once you tighten these bolts up or you start to snug them up, that they're not bottoming out on the flywheel. It's hard to see up inside there, but because it's so close to the center, the ring gear is actually behind this threaded hole. Now, I know you can't see through there, but if you could see part of the ring gear. You could see part of this surface right here. So you don't want to tighten, you don't want the bolts to be too long, so you want to be real careful about your depth of your bolt. And you'll have to do that on all 3 of these bolts. Okay, we have the clutch bolted on, and we want to talk about the clutch a little bit. Whenever you put any kind of engine in the Fiero transmission or any of the other front-wheel drive type transmissions, General Motors doesn't use a pilot bushing in the end of the crankshaft on any of the engines. And when you don't use a pilot bushing, you can't use a clutch alignment tool to align the clutch. So as we're tightening the or snugging up the clutch to the flywheel, we're aligning the clutch by feeling around the edges of how it's fitting around the edges in the 3 areas here. We try to get the same distance. You put your finger in there, you can get a feel for it to try to get the hub in the center. You can't use an alignment tool because there's no pilot bushing inside the end of the crankshaft. If you decide you'd like to put a pilot bushing on the inside of the crankshaft so that you can use a clutch aligning tool, you don't have to worry about getting in the way. It's just an added expense for you. But if you put a bullet bushing in there, the alignment tool will reach all the way into the bushing. But if you check it out, or try, you got to trust me, I've been doing this 21 years. There's no pilot bushing on any front-wheel drive GM stick-shift transmission. And but if you want to put a bushing in there, you don't have to worry about the input shaft in your transmission interfering with that pilot bushing if you put one in your crankshaft, because that shaft doesn't go anywhere near deep enough to to go all the way into a pilot bushing or to even touch a pilot bushing. Okay, we're going to put the starter on. Starter's going to go in over here into this area, and you'll note that I told you before we ground just a little bit off the corner of the block right here, and we ground just a little bit off the oil pan here when we were working on that. When we get the starter up in there, you'll be able to see why. Okay, we're getting ready to do the starter mounting. On the starter, when you get it, it has this aluminum block mounted to it, and what you have to do is you have to take this off. Our new starter mounting block, you can see calling this a block is actually an understatement. It's a lot more complicated than the one we take off the starter. But this one comes off. There's 3 screws. One of them comes through from this side, you know, through the counterboard holes on this side, and the other 2 come through these 2 holes right here, one here and then the one over here. Okay, in this case we have put the new starter mounting block on it as starter, right where the old one was, and we align the holes. There's one here and 2 over here. We align the holes, and sometimes you got to tap this starter block on because it's a interference fit, and the bearing in here is a slip fit. You know, it's a real close fit, so sometimes you got to tap it on real careful. Just tap it on and get it square. Normally, on most of the LS kits we've sold so far, we pre-assemble the starter onto the adapter plate for people. And the reason we're going through these instructions is someday the day is going to come where I sell a kit and I don't have a LS engine in the shop that I can trial fit everything to for you, so you're going to have to put it together yourself at some point. Some of this assembly might already be done when you get your kit. And once we put the screws in, we have this short Allen screw is going to go in through this counterbore hole, screw into the starter, and then these 2 screws will go in, and then we'll get this starter over and mount it up to the engine. Okay, we have the starter all bolted on to the starter mounting block. Space is at a premium. That's why this starter mounting block is machined so intricately, is because there's just barely enough room for all this to clear the block. You'll note in this area, remember I showed you the thin walls that were on the business end of the starter block. In this area, the casting of the starter is just a little bit above where my, this area right here where my finger is, and we're going to grind this flush down here to bring it down to this surface here, make it just a little bit more clearance right in this area. If you look in here real close, the area I was just talking about grinding is right in this area, and you see it's real close to the engine block. Rob's holding this up here just to give us an example. And it's real close. We don't know if it's touching or not, but we'll grind that back just a little bit, and we'll be good. Then we'll bolt the starter on. See, this is the area where we ground this flush right through here. And when we go to put this onto the engine, it's the same area as this little grinding we did here on the edge of the oil pan. That's right in the same area. Go ahead, Rob. Okay, we've bolted the starter on. It's not up tight yet with these 2 Allen screws. There's still a little bit of movement or a little bit of play in the starter drive or the starter mounting, and we got to align this the gear, the pinion gear to the ring gear that's on the flywheel, and we'll pull that out with a pair of needle nose pliers and set the alignment per the instructions that come with the starter. Okay, what we have here are the water pump adapters for when we do the LS swaps in a barrel. we use a remote electric water pump, and we have some billet fittings here that are made for the purpose of supplying fittings onto the front of the engine so that we can route hoses over to the remote pump. You'll see this one has an L on it, and the other one has an R on it. One goes on the left, one goes on the right. The right one goes on the right side engine bank as the engine was originally mounted in the car. In other words, the even side of the engine bank. And this is one of the gaskets that was on the original water pump, and we'll reuse that gasket since it's a brand new engine. We'll reuse that gasket on these fittings. If you're using a used engine, I suggest buying new gaskets. Okay, here we're looking at the front of the engine. The remote water pump fittings are on the front of the engine. The left side one is on the left bank of the engine, and the right side one is on the right side of the bank of the engine. And the bolts we're using are the bolts that we're holding on the original exhaust manifolds. Brand new bolts, no point in replacing them because they'll bolt these on. They won't work with the headers. The headers have their own bolts. And typically on 84 through 87 Furos using an LS engine, we'll use this half inch pipe thread 3/4 heater hose fitting, and they screw right into the front of our fittings, and we just use 4 of those. The reason we have the letters out on the engine on these pieces is because it's a tapered thread. It's a national pipe thread, and national pipe thread you should try to screw in from the right direction. That's why they're labeled left and right. Otherwise, they're identical pieces, except if I had this piece over on the wrong side of the engine, then the threads are going the wrong direction. You know, you're not going to be able to screw the threads in. So that's why they're labeled left and right. And then on an 88 car, we have to use a street elbow through this hole to clear the strut tower, because the strut towers are more intrusive into the engine compartment than they are on 84 through 87s. But we'll be looking at that when we do our trial fitting and stuff in a little bit. We also have the headers on. The headers come with their own bolts, and of course they have collectors, but once you get the headers on, you also want to put in the dipstick. We use a Allen head cap screw to screw it into the cylinder head, and just put it on just like it came off of the original exhaust manifolds. That's basically the same installation. And we'll find a couple other little things to do to this before the car gets here. We're still waiting for the car to get here. We're trying to do as much work to this before the car gets here as we can. We also have an alternator bracket, a new alternator bracket that's going to bolt onto the front end of the cylinder head in this general area. It's going to have an idler on it and everything. And when we get this engine and the setup, start putting it on the cradle, we'll show you the alternator bracket and the mounting of that. Okay, for our instruction video, this is our victim. It came in yesterday. Today's Tuesday. It came in on Monday. It was driven here from New Jersey. I would guess that's about 1,000 miles, 1,200 miles. We're about 70 miles west of Chicago, whatever that works out to. It's an 88 GT. It's actually a low mileage car, and it's in pretty good shape. Pretty good shape. The engine that's in the car right now is a V6 turbo. It's a Design 1 turbo from Design 1 out of Oklahoma, and it's got a bunch of features on it. And the engine, the customer wants to sell the engine. Engine exhaust system, ECM, boost gauge, and everything else that goes with it. So I'm going to be doing a video on that separately and whatever. And but this will be getting the LS3 swap, and we're going to start on that in a few minutes. Okay, we're going to get started on our V8 swap. First thing we're going to do is remove the deck lid and remove these 2 engine covers on either side of the engine. And we'll start disconnecting as many things from the top as we can. Once we get as much disconnect from the top as we can, we're going to jack this thing up in the air and drain the coolant out of it and start disconnecting things from underneath so we can get this engine out of here for putting in that pretty engine that we've been working on. Okay, we got the deck lid off, and so we're disconnecting the air cleaner hoses, and this cruise control unit here is going to come out of the car completely. It won't be going back in because the electronic throttle body on the LSx V has the cruise control controlled by the ECM. We'll be taking the battery out from that area there, and we'll be disconnecting hoses and everything else we can from the top before we put the car up in the air, and then we'll be doing basically the same thing from underneath. We have a lot of the stuff disconnected now. We have the throttle cable disconnected. We took the cruise control unit out. The shift cables are disconnected. The wiring has been unplugged from this unit here. The big plug has been unplugged from here, and it's laying right up here. We're going to take the wiring harness out with the engine. That's the easy way to do it. And you take the wiring harness out with the engine, then once you get the engine and transmission cradle assembly set up on a workbench, you can take the wiring harness off real easy. We're going to take off this dog bone here because that's still tying it to the chassis, and it's got a turbo on it. We're going to try to take the turbo out with the wiring harness and everything attached so we can remove it cleanly. And most everything's disconnected that we can reach from the top right now. We're going to go inside the car and take out the center console, the back part of center console, so we can unplug the wires from the ECM and bring them through the bulkhead, because they'll come out with the harness here will come out with the engine. So that's the next thing we're going to do, and then we'll bring you up to speed when we get there. Okay, inside the car, we've taken out the center console all the way up to the shifter, and we've unplugged all the wires from the ECM down here and unplugged these two white plugs from the harness that remains in the car, from these two black plugs here. Kind of hard to see. Part of the turbo system is what I think is the burn-off relay. We're going to take this out with the harness. We'll actually unplug it when we take it out through the hole, and then we'll plug it back in. And the turbo boost gauge was connected with a tube and a couple wires, and the tube had a plug right in this area here, where two pieces of tube plugged together. We unplugged it there, and it'll all go out through this hole where the harness is. It's going to go out right out through this hole, all this harness, and then we'll be laying that over the top of the engine as we pull the engine out. Okay, just for reference, I have that little deal going on where didn't have enough light on a few shots, and the interior shot, we're going back videotaping this about 4 days after the original thing was videotaped, so I've already got other work done. But you can see this is the hole where the wiring harness fed out of the engine compartment, or out of the passenger compartment into the engine compartment. And I'm going to show you the plugs where the wiring harness was plugged in. These two plugs right here, the black ones, were plugged into clear colored plugs. And we've taken out the ECM since we pulled the harness, but just thought I'd show you what it's supposed to look like when there's lighting. And then the up here, the ALDL plug that was mounted right up here behind the cigarette lighter, we took that out with the wiring harness too. Okay, we have the car up in the air for doing the swap. What we've done is we have jack stands underneath the front cross member, and the front tire is about 8 inches off the floor. The top of the rear wheel well right in this area, is 40. This one right now is 45.5 inches up, and 45 inches will be enough. And when we lower the engine out of the car, the engine cradle and everything, it'll roll out through the right side wheel well. So if you go up 45 inches and use a dolly underneath there that isn't too tall, you'll be able to roll it out through this wheel well over here on this side. And we're going to get underneath the car and take off the brake and the wheels and things like that, and disconnect all the cables and junk from underneath and start getting ready to lower the engine cradle assembly out of the car. Okay, so we're getting ready to lower the engine out. We've removed the disc brake caliper and hung it up here out of the way, and we removed the handbrake cables, and there's one of them tied up out of the way right there in front of you, and we removed the hose from the coolant pipe. Of course, we took out the inner wheel well liners. We did this basically on both sides of the car, and disconnect anything else we could find from underneath that we could reach. You know, handbrake cables, I said that. Same thing over here, took out the inner wheel well liner. And we're going to hook up the overhead A-frame to it and start lowering it out, start getting ready to lower it out of there. We're going to lower it out real careful because there's a lot of turbo stuff in there that we want to make sure is, we don't yank a wire out or something. Okay, so we have it hooked up to the overhead hoist so we can lower the engine out, engine cradle and assembly out. We're going to put it on this little dolly we have here, which is we've been using for several years. And just watch all our wires and everything around the engine as we go down to make sure nothing catches or anything on the way out. Make it nice and clean so we don't yank a cable or something. And we'll lower it down onto the cradle and roll it out, or onto that dolly, and roll it out from underneath the car. And as we take this out, we're taking out the suspension with the engine assembly, suspension and everything. All we did was take the brake calipers off the hubs. And these 3 bolts that are holding the strut at the top of the shock tower, you got to take the 3 bolts out and take that plate off the top of here. On 84 through 87, you have 3 different plates, but same idea. To get the strut to come out with the cradle, you have to take out these bolts. And over here you can see we've taken out the bolts and the strut's already dropped down, so it's ready to go out right now. So we'll lower it out and be in business. I should have got some video of the thing coming out of the car, but this is what it looks like as soon as it's out from underneath the car. Suspension, everything's still on it. Still got the turbo and everything else still on it. And AC compressor, AC line still on it. We're going to roll it over underneath the A-frame and pick it up and set it on a workbench and start in on it. Okay, so we're going to continue with disassembly, the engine cradle and stuff now that we got it up in the air. The exhaust system gets taken off at this point. This has a turbo on it. The turbo is being resold, so we're going to try to take off as little stuff as possible. It does look like we'll have to take the exhaust off at some point to get it out from underneath the cradle, because it does go up under the cradle. But at any rate, if you're working on a Fiero and you're doing an LS conversion, enough about that turbo already. We typically get the engine up in the air, hanging from the A-frame like it is, and then we take the exhaust system off while it's up here like this, and then we set it on the table. We have a roll-around table we work off of, and we set it on the table and start pulling the wiring harness off the engine and the suspension off, and start getting this thing ready to put the LS engine to fit it onto the cradle. So we'll be taking the exhaust system off and join you when we get this sitting on the work table. Okay, back to the instructions. We're taking off the wiring harness. We got the cradle off from underneath it, as you saw, or as you can see, and we're taking all the wiring off, and what we do is typically, we don't cut any wires. We actually unplug everything. We start over here on this side of the engine and just work our way around the front, and then down and take all the wires off with the harness and all the plugs, the bulkhead connector, all that stuff is going to come all off in one piece. And then later, when we describe the wiring harness, here's your bulkhead connector. We will, when we talk about a wiring harness later, we'll go through each and every wire in the harness and talk about them. Okay, there's the cradle. We got the engine and cradle separated. The engine is, we've got everything we want off the engine. The only thing we really need off the engine once we had transmission off is the water temperature sensor, which is right here in this cylinder head. A water temperature sensor, because we still use a stock gauge in the Fiero, so we use that water temperature sensor to operate the gauge. And we got that all disassembled. And then this is the transmission. We're going to subject it to some serious cleaning and get it ready to go back in the car and start building and putting the LS3 and the engine cradle and stuff together tomorrow. Okay, we power washed the engine cradle and we have it all cleaned up and we're getting ready to do our work to it. Up here in this area, we've removed the original front Fiero engine mount. We've cut that off the cradle and ground down the weld so it's pretty. And then we'll be putting a cross member in alongside this original cross member, and then we'll be taking that cross member out. There'll be a 1 inch by 3.5 inch box tubing going, or heavy wall box tubing going across there, replacing that cross member. As it turns out, with the LS engine sitting on the cradle, we can use the stock oil filter mounting on the LS engine if we move this frame rail a little bit, and it's a lot better than using a remote filter. We have to use a remote filter on a normal small block Chevy, but on the LS engine, because of the way the filter is mounted, we can, it's harder to do a remote oil filter kit the way the filter is mounted on the LS engine. And we can eliminate needing to do that by putting a cross member across there. It gives a little bit more room around the oil pan too. The oil pan's wider on the LS engine, so we need the room. And we'll show you that as we go. Okay, we're in process on putting in the cross member on the engine cradle. And what we're using is a 1 inch by 3 inch heavy wall box tubing. And this piece comes with the kit. However, you'll notice that the piece we have here is bent slightly. We can't pre-bend them because they're actually bent to match the cradle. So what we're doing is we're putting it in. Rod's going to show you, going to place it up where it goes. And you can see that at the far end it is bent to match the face of the cradle, or the edge of the original front cross member, and then it comes down and it steps over a little bit to match the edge of this. Now we're going to take it off there for a second. I'm going to talk about it, and then we'll put it back on there. When we get done with this, we're actually putting in this cross member before we take out the old one. And the old one will get cut off and removed, but the stub, there'll be some stubs sticking out here at this end, and there'll still be stubs sticking out at the other end too. That's why we don't take the member out before we put the second one in. And you'll notice on the edges here, he's ground the edges to get ready, you know, to get a good surface for welding. Ground the edges down here, and then down here on this end, I got a little video that you just looked at that shows him cutting off the lip on the lip that sticks out from this end of the cradle cross member. There's a little lip that sticks out, and we'd use a plasma cutter and cut that off. You can cut it off with a saw too and grind it flush. Now why don't we set that thing back up there, Rob, and show it again. He's not quite done fitting it all yet, but it's basically going to go in there like that. It's going to get welded into place. And then the original cradle the original cradle cross member is going to get cut out once this is all in place and welded in solid. Okay, he's about ready to tack weld in this bar that goes across here. The bar is just pounded out to bend it. It's just with a hammer and a solid piece of steel underneath it. You can bend it over, and that's what he's doing here. And now we have it C-clamped into place. The ends, of course, are flush with the top edge of the cradle in this area here. Same thing down at the other end. And got it C-clamped into place, and he's going to tack weld it into place and continue. We'll keep you. I'll try to show you each step of this as we go, or at least enough that you can know what's going on with it. Okay, we have this welded in top and bottom over here on this side, and we have it welded in on the end and down the face of the weld here and underneath. We're getting ready to cut out the original cross member. And what we're going to do at this end, we're going to cut it about the center of this hole here, just on the left side of my stick here. Going to cut it right about center of this hole here. We'll be cutting off the Fiero cradle all the way over to the new bar, and then we're going to be adding some angle iron in there. You'll see an angle piece. And then down at this end, we're going to cut it approximately right through here, just about even with the inside of this rail. We'll be cutting it here, and then eventually we're going to be doing a little bit of cutting to knock this down, because the AC compressor mounts in this area, and this hump will get in the way on the 88 car. And we'll be cutting those down, and then he's going to, like I said, he's going to be putting an angle in here to close off the end of the original frame rail, and also to reinforce where it's mounted. There'll be plenty of welding done. And the same thing down here. This will eventually be cut down a little bit, plus there'll be an angle put in here to close off the end. And at some point, we'll be cutting a radius in the face of this for the exhaust to come through. And we'll try to show you that as we get it done. Okay, so here you can see that we put a piece of angle piece in here and welded it to the new cross member and boxed in the end of the frame rail. This is an 88 car, so when you route your brake cable, your handbrake cable through here, you'll have to put a hole through here to put the cable in, and then along in here, you'll have to put a mount for the other end of the cable, to replace the ones that were in the cross member that were taken out. Over here on this end, as you see, we've got this cut off, and then this area here where the hole is, this used to come up, rise up. We've cut it down and flattened it out, and this will get welded in around here. And then we have a notch cut through the cradle for the exhaust to come through. We've cut a radius in here through both walls of this box tubing, and you're right, that'll weaken the box tubing just a little bit, but we've got another piece here that is going to go in to also box in the end of this frame rail. This piece is going to go in like this, which will box off the end of the frame rail, also the end of the original frame rail, and also it'll when it welds onto here, we'll also cut a radius in that for the exhaust to clear, and it'll beef up the strength of this 3 by 1 inch box tubing that's on here. So that's still got to go in there. Okay, let me bring you up to speed on what's happened since we left you last. The angle that we were showing you, we're putting in, Rob's got that in. It's right here, welded in all the way around. And he trimmed this end down. We're going to look down into this pocket here in a minute. And once he had all that welded in, he took a piece of flat metal stock, an inch wide, and hammered it out to form this radius to close in all of this, the open area from this cutout for the exhaust. And he welded that piece in. Down here in the pocket, you can see the bar was welded in along this line here. As I said, this surface here was cut down just to make a nice clean little pocket. It's been welded all the way around inside there. going down here, remember we talked about having to put in the brake cables. This is an 88 car. You don't have to do this in 84 through 87. But on the 88, you're going to put in your handbrake cables. He cut a radius down into here to clear the cable as it comes through here. You'll know that the driver's side cable comes through from the outside engine cradle, and it comes through this hole right here, and then it just needed clearance through here, so we cut a radius into it, and then we needed a place to mount the end of the cable, and we made a bracket and with a hole in it for the cable to go through. The way that we determine where that cable has to go through is to use the old cross member piece that we cut out, and that's the cable we used to go through right here. Okay, so he made a new bracket to have the cable come through here. This particular bracket was just cut off of a bracket from an extra caliper we had laying around. You could cut this piece out of here if you wanted to and then put it in over here, or just make yourself a flat piece of stock, put a hole in it. And that'll hold the end of the cable that comes from the driver's side. And then, of course, there'll be the connector through here and going over to the other side. Okay, and now once we've got our cable coming through here, the cable from the passenger side of the car comes through the inside of the original frame rail, and it comes over and it attaches right here. The cable mounts right here. So we made this little mounting bracket. You can cut out the old mounting bracket, or you can just make one like we did out of a brake cable bracket from a discarded caliper. And the location for where this bracket has to be is pretty easy by just setting the cross member piece that you cut out in here where it belongs, and you can see where the bracket needs to be. Now the right side passenger side cable comes through, and it mounts into this bracket, and then right here in between is where the cables attach together, you know, where the adjustment is. I think that explains it. Now, that's pretty much all the modifications we have to do to the engine cradle. We're going to move on, go over and take a look at the transmission now, because we cleaned up the transmission and stuff, so we'll take a look at that next. Okay, we've cleaned and painted the transmission, cleaned it up really well, and then put a nice good coat of semi-gloss paint on it. And we put a new throwout bearing in it. And we lubed up the cross shaft. You know, sometimes they're a little bit stiff. We lubed that up. And sometimes when you come over here on this side, this nut right here, this bolt right here, sticks out too far. And sometimes you'll see scratch marks on the case where it rubs the case. You want to inspect that area right there. And if it is rubbing the case, then you just grab a hold, pull the bolt out, and put a couple of washers on this side of it so the bolt don't extend through so far. That's a common thing with Fioros, is that bolt will be rubbing the case, and it'll keep the clutch arm from returning. You know, when you release the clutch. There's any scratches on this case, so it's not a big deal. And also we put in the output shaft bearing seal assemblies. We get these from Rodney Dickman. You can get them from several other sources, but they are required if you're doing a 5-speed Getrag or any stock Fiero transmission with an LS engine. And then next thing we're going to do is mount this thing up to the engine. The engine's standing over here waiting for it. And we're going to put her on the engine and start mounting this assembly up to the engine cradle. Okay, we have the transmission bolted up to the engine. Sometimes it's a two-man job. Sometimes it's hard to do one guy, and we got it hanging up in the air. When you have it, if you're doing it by yourself, I'd suggest you set the engine down on the floor and get a good solid mounting. And when you go to put it on, do it first thing in the morning when you got some patience, because sometimes you got to handle it for a few minutes before it goes in. Now you'll remember we talked way back when about 3 of the holes intersecting with the flywheel. Okay, and the bolts that we're putting in are 7/16 thread, 7/16 14 thread, and they're 1.5 inches long. 3 of the bolts are 1.5 inches long. 2 of them are 2.5 inches long. The 2.5 inch long bolts go in these top 2 bolts. The other 3, this one, and then over here on this side, they're going to be 1.5 inch long bolts. That way you won't bottom these bolts out on the flywheel. Remember, if you don't remember, you can go back in the video and look at early on when we were talking about the adapter plate and the bolts in the transmission. Okay, then we're going to get the cradle up here and start fitting this thing to the cradle. Okay, right now we're up to probably the most important part of the whole swap, and that's getting the engine on the cradle in exactly the right spot so that everything fits. It's pretty important on this setup to get everything in the right place so that the engine's square in the engine compartment and there's enough clearance for everything. What we're about to go through is for an 88 car. We'll discuss the differences between 88 and 84 as we go. And also, this would also apply to doing an LS swap with a 6-speed also. This whole assembly is still in the same place it would be if it was a 6-speed. All right, so try to remember these dimensions are ones I want you to keep, and if you move one of them, it's going to affect the others. So you've got to go back and recheck all the other dimensions if you move one of them to adjust for one thing or the other. To get this engine transmission assembly into position, we've actually blocked it up. We've got a 2x4 and a stick underneath this thing to get it where we want it. We've got a little block underneath the front end of the oil pan, and then if we walk over here to the other side of the engine, we have the forward transmission mount bolted to the transmission, but it's not welded down to the mount or anything here yet. This gets us in our position so that we can start taking all these measurements. Okay, so the first dimension we're going to check, and this is on an 88 cradle, is going to be the center from the top of the frame rail here to the center line of the output shaft on a transmission is 3 3/8 inches. On this is an 88. On an 84 through 87, that dimension is 3.5 inches. Okay, and then we have a dimension from the horizontal bolt hole on the engine cradle to the center line of the crankshaft, and you want to have 16.25 inches right here. That'll be the same whether it's an 84, 87, 88. All cradles will be this same number here. Now this is a reference dimension for 88 cradles only, and 5-speed Getrags only. We have 2.25 inches over to this lip on the frame rail from the little nubby that sticks out in the transmission. Of course, you don't have that nubby on other transmissions, and you don't have this line on 84 through 87 cradles. That's it. Stick to it. Okay, the next thing we're going to do is we're going to measure center to center on these holes for the vertical bolts, center to center. Now, this is an 88 cradle. 84 to 87 is going to be a different dimension, but we're still finding the center of the engine cradle by the same method. We're going to take total distance. What we want to have when we're done is we want to have the transmission face of the adapter plate 6 inches to the left of the center of the cradle. And so you're determining the center of the cradle by measuring left to right from center to center. And right now that's 36 inches. Half of that's 18 inches, and plus 6 inches means 24 inches. So we put straight edge up against the adapter plate and come over here, and you can see that we're at 24 inches. Now, to make sure that this engine's in the car square, we want it to be parallel. So what we've done is we put a straight edge across the engine cradle mounting pads, and it's right at the edge of the holes, the holes for the two vertical bolts. And then we're going to come over and measure to this pad right here and this pad to see that those two are parallel to this straight edge. And we'll adjust accordingly. But you're going to measure right over to the edge. This dimension, the actual dimension doesn't matter. What matters is that they're both the same. Any adjustments to that dimension is going to change your dimension for the location left to right, because your straight edge comes off of here and it comes out, and if those last two, the checking parallelism is off 1/8 of an inch, this is going to be off 1/8 of an inch. So you got to go back and recheck dimensions. And then the big thing, another big thing, is getting the engine in the car level. And the easiest way to do that is with our straight edge. You can sight right over the top of the straight edge and see the edge of the oil pan, where the oil pan meets the engine. You can sight that, you can sight it from underneath, and you can sight just about anything you want. Plus, you can check it with a level by bringing your level up here. Now, we're not looking for actual level, we're looking for duplication between the bubble position here and the bubble position down here on top of this bar. Because we don't know that our table we're working off of is perfectly level, so we're just comparing two levels. Okay, we're working on the mounts for mounting the engine onto the cradle on the LS swap with the 5-speed. This is one of the mounts that we send to you, and we also send you a piece that looks like this. This piece isn't necessarily drilled here, and you may have to tweak this angle here a little bit on this turn and drill these holes, and it'll mount in here like this. We haven't welded these yet. We're getting ready to tack weld them, and there's also a gusset that goes up underneath here to support it. That's basically what it is. We're going to tack all these in. This mount on the transmission is pretty simple. We have a piece of angle setting here. We did notch this out to make clearance for putting this bolt in, and we have a piece of bar stock behind there. They'll all get welded together. The angle and the bar stock will get welded to each other, and in such a position that the line's up. So what he's going to do now is he's going to tack weld this piece on here and come around here and tack weld this on, so that when we take it off, we can weld it all the way around. Now, you saw this mount earlier. This is a piece of angle setting on the top of the frame rail, and this piece, we haven't done anything with this other than just grind the surfaces so when they're welded together, we get a good weld. This will get welded or tacked on right where it is right here, and we're going to get back to this mount later, because it actually bolts to the cradle. So when we turn the cradle over, this piece here will be tacked on. When we turn it over, we'll drill some holes through, so we got a couple of bolts, and then we'll just cut the tack welds. Okay, now we're on the front side of the engine, and we have a piece of rectangular plate with 4 holes in it, and it's bolted right up to the LS engine mount area. Then we're going to put a bar on that goes up here. Now this bar, when you get it, isn't necessarily trimmed exactly like it is right now, because you got to fit this as you go, so you're going to have to do some cutting and angle on it. We have this thing going in here at an angle on purpose. It's not going straight up and down, it's going back at an angle to clear the lines that are going to be on the back of the AC compressor. And then we have this little triangular gusset that's going to go in there to once again reinforce that position of that piece. But when we do it this way, we have room for the AC lines off the back of the compressor. If we just put this box in vertically, there's less room for the AC lines. And that's it. Going to tack all these in and show you what's going on. Okay, we've got the mounts tack welded on, and at some point here we're going to do some trial fitting of the engine into the car. Before we actually finish welding them, we'll do a trial fit on that thing. Let's go take a look at the other mount, the one on the front side. There we go. They'll be all welded up solid, good before we put it in for the last time. But we usually do a trial fitting of the cradle and everything, and then we just take the engine back off the cradle and paint everything and make it all pretty. Okay, here we are in the engine compartment. We've taken all the insulation off the walls, off the front wall and the two side walls. We're going to be taking out the battery tray because we'll be relocating the battery. And on the LS engine, I'm going to show you a spot here. See where this triangle is and where this bracket is. They used to have the dog bone hooked up to it. On most small block Chevys, you can just leave that in there if you don't care. You don't care about what it looks like. But on the LS engines, you have to take this out. You have to trim this out. You can see what it looks like right now, and I'm going to take you over and show you what it on the other car that we're building on. I'll show you what it looks like after it's trimmed out, and then we'll come back here. So here's the same area on the black car where we're also working on. It's been trimmed out, and you can't even tell it was there. But the oil fill on the valve cover is right here, and it's the only place you really can put it when you're using the injector covers or the coil covers that come with that we put on these engines. You got to keep your oil located here, otherwise there's no real place to get to. You can't really put on those covers if you got this thing trying to get this thing under the cover. Anyway, that's why we take it off, and it looks better. Okay, elsewhere in the engine compartment, we're going to be notching the right side frame rail. We'll be showing you a lot more detail of that, but it's the frame rail is right there underneath the battery tray. And we'll be making a notch in that for the harmonic balancer pulley. And the bottom of the hinge box, we'll be notching the bottom of the hinge box to clear the coil packs. And one of these torsion bars that holds the deck lid open will have to be coming off. Typically, we just take both of them off and then we put a Rodney Dickman strut on. That's what we'll be doing on this car. Let me show you what all that looks like on this other car we have over here. Okay, we're not done building this car yet. We've still got a few things to put together, but you can see how the hinge box has been trimmed off. We're going to show you on our subject car, I'll show you this hinge box too. And then, because the coil packs and all this stuff in the way here, we take out the torsion rods for the deck lid hinges, and we'll just put a Rodney Dickman strut on there. But this is basically how it looks when it's getting closer to being finished. We'll show you on the engine compartment the detail on our subject car. So when we do the LS engine swap into Puro, we modify the right side frame rail. And right now I'm showing you what it looks like before we modify it. And also before we modify it, we put in a steel reinforcement plate on the outside of the frame rail. This piece, as you can see, it's outlined here. It was cut out of a 3/8 inch flat stock and then hammered to shape to follow the frame rail just a little bit. We're not cutting out that big of a section on the frame rail on the other side. We just extend our weld down go past the openings on both ends, just to make a nice, strong reinforcement here. We C-clamp this piece on and then weld it, and as you can see, it's already been welded all the way around, and then the welds have been ground already. And then on the inside, we're going to go ahead and make our cuts, our initial cuts that we make. Show you a video of that, and then we'll show you a video of it as it's moved over a little bit. We'll show you. And this is the view into the wheel well of our plate that we have on the side of the frame rail. Of course, it's been painted now, but you can still see the definition of it. And I talked about a way earlier about hanging the caliper out of the way. We hang it back in here. This is a view looking down on the frame rail that's on the right-hand side. We haven't done any notching yet. This is what it looks like stock. And we'll show you what it looks like after we've done our little cut, and then you'll see it'll be pretty easy to do. All right, we've come in here and made a couple of cuts for our modification of frame rail. We have from this little part of frame rail here, or this front bulkhead, we went back 19 inches, and then we cut a vertical cut right here, and then up on top of the frame rail, we've got a notch out. We've gone back on the top rail and the bottom rail of the frame rail. We've gone back to where it's to the outside wall of the frame rail here. And then what happens, we have to shorten this up right here where this 19-inch cut is. Got to shorten that piece up a little bit, and then this piece will push in here, and then it'll be welded all along here, top and bottom both. And then it'll be boxed in right here on the end, and it'll be done. So we'll show you this in process here as we go. Okay, as you can see here, we've cut about 3/8 of an inch off at the end of that 19-inch dimension. And now we're going to pull that in with a C-clamp, and we'll show you it in a sec. Okay, what we've done here is we've taken, where we cut the slot out, we've put some C-clamps on there and pulled this piece in all along here. See, that way the frame rail here is pretty much going straight back here. And we'll be coming around here and boxing in the end of this open frame rail here. This has been pulled in, and there'll be a weld put all the way down all along the edge there, both top and bottom. And that's the modification we got to make. It just makes everything a lot easier when you're doing the LS swap to get the pulleys on all the belts, have room for the pulleys and all that. We'll show you what it looks like when it's all put back together. Before it's painted though, because you can see a lot more detail before it's all one color. Okay, we're just about ready to do a trial fitting on the engine into the engine compartment. You can see that we trimmed back the hinge for the right side hinge box. We trimmed it back, trimmed it up for clearance around the coils and the valve cover. And you can see that we made a cut about 1 inch below the top hinge bolt stud thing, and then tapered that cut back parallel to the front bulkhead. And also, we took out the strut mounting over here, like we discussed a little bit ago, for the engine torque, what do you call that, dog bone. And we took that out of there, and also took out the battery tray. Of course, the battery tray was out before. We showed you frame rails and stuff before. And we did some welding, and if we finished welding that notch or that movement of the frame rail, we still have to box it in and stuff. That's not done yet, but it was just a trial fit we went for here. We're going to trial fit the engine, and then we'll go to work on seeing how that fits. Here's another view of the hinge box. Okay, as I edited this video instruction tape, I found that some of the views inside the engine compartment were pretty lacking because they didn't have enough light. So over the next few minutes of this video instruction tape, there's going to be insertions of video like this that are showing the features with proper lighting. Can't go back and redo it because we're way past that part of construction, but at least I can show you what it's supposed to look like. This would be the frame rail. You can see the weld all along the top edge of the rail along here. You can see that this rail is basically straight on a stock Furo. It's straight here, and it starts to come out towards me. And we just more or less made it straight all the way back. And here's the boxing in of the end of it. Also, we talked about the hinge being cut back to clear the coil packs. You can see that. We also took out the dog bone mount over in here. That's a little bit clearer view of the same thing. We talked about a 19-inch dimension. That 19-inch dimension started right here, and it came back to where we made this original cut here. Okay, I'm going to go take a look at the outside of the frame rail through the wheel well. And this is the view into the wheel well of our plate that we have on the side of the frame rail. Of course, it's been painted now, but you can still see the definition of it. And I talked about a way earlier about hanging the caliper out of the way. We hang it back in here. Okay, we've got the engine up in the car for the initial test fitting. We've still got some welding to do on the mounts on the cradle and all that kind of stuff. And but we usually put it up in here for initial test fitting just to see how it looks and how it fits and make sure everything looks good. We've got some of the things we look for during the initial test fitting are make sure the engine's level in the car. You can see that it is if you just eyeball the fuel rails. And we also check for the fit. Looking down here at the harmonic balancer pulley to the frame rail, and we got at least a ½ inch there. And then looking down at the tail of the transmission where it comes up close to the frame rail, it's hard to see here, but there's about a 1/16 of an inch of clearance. One spot there where we're going to tap it with a hammer and move it back in just a little bit. And we can see from this view that the engine's square in the car. That's why we did all that measuring we talked about earlier. We have the engine out of the car now after the first trial fit. We're going to go through and weld up everything. You know, a lot of stuff's spot welded right now, and we're going to go through and weld up everything. First thing we're going to do is mark the holes that we're going to need to drill into this mount for bolting this mount down. We just go up underneath there with a spray can, and we just spray the underside of it so that the paint goes up through the holes that are in the cradle already and marks this piece. And when we take it all apart, we'll know where to drill the holes by where it's painted. So after the trial fitting, we can, which we've done, we can go through and weld up everything, get it, finalize all the welding, and do the painting. Make it pretty. Okay, in the engine compartment, we've finished our welding project. We've boxed in the end of this rail here and welded it all along the top and along the bottom. And we've made this nice and smooth through here, so it'll look good when you put paint on it. I'm showing it to you now before paint because you can't hardly see it after paint. And you see when we brought this rail over, we brought it over so it's right in a straight line with this, and that'll give us plenty of clearance. This engine compartment's ready to be painted now, and we're painting the engine cradle right now too. All the welding's been done to the cradle, and we're in the process of painting it right now. and we'll get it all painted, and then we'll start putting the engine onto the cradle for the last time and getting it all bolted together. And of course, all the fasteners that you use for the engine cradle, you know, every bolt you put in, you pretty much should put Loctite on them or whatever. And so I'm not going to cover Loctiting with bolts and stuff like that. It's common sense. Okay, last time we were with you, the engine compartment had been painted. Now Rob's put back together virtually everything in here. On the forward bulkhead, we put in some insulation material. That's similar to this right here. It's a foil on one side and jute back on the other side, and it's put on there with contact cement to spray on 3M style contact cement. And then over in the right inner wheel well, he put the wiring harness, the chassis wiring harness, back in position where it was before. And then he's got the shift cables in and located. He's got the vacuum line in, the original vacuum line for power brakes, and got all the stuff located that we moved out of the way to keep it from getting painted when the painting was done. The shift cables for right now are just up hanging over the top of the hinge box. And then when we painted it, we took the brake lines away from the bulkhead, so we weren't painting the brake lines too, so those are all back in place. And the engine compartment's virtually ready for the engine to go back into. The next thing we got to do is get all the engine put together. We got to put the engine back on the cradle and put the alternator on, the alternator bracket, and all the other bracketry, AC brackets, all that kind of stuff that we can put on before we put the engine in the car. A lot of that stuff can be put on outside the car, and that way it makes it easier once you put it in here. Okay, we have the engine mounted back on the cradle. Cradle's all painted up ready and everything. All the bolts are in on all the mounts. It's mounted on there for the last time. And we're going to be putting the accessories and stuff on the front end of the engine here pretty quick. And getting this thing ready to put in the car for the last time. Quite a few things we can do outside the car. That's the nice thing about these swaps is you do the swap standing up, walking around the cradle as it's setting up here like this. Most of the work is like this, a lot less work hanging over the fender and laying under the car. Okay, we're getting ready to put the AC compressor onto the engine. The AC compressor bracket is this S-shaped one here. And on the AC compressor, there's several different AC compressors used on Fieros. Some of them have 3 mounting flanges on them like this one does. Some of them have a 4th mounting flange over here. And also they have different spacing between the pulleys and the mounting flanges, different distances. You know, and some of them have V-groove pulleys and some of them have serpentine pulleys. On this particular one, it had a V-groove pulley. It's from an 88 GT. And we switched the pulley over. Your local AC shop can do that for you, depending upon what pulleys are on there to start out with. When we put the lines on the AC compressor, thing to remember is that the smaller hole, usually it's a little bit dirtier inside, is going to be the smaller line on these on the AC lines. Typically it's got the air dryer on it, but you see the diameter of this line is smaller, and you can see in this right hole here it's smaller. So when this line is going to go on to the AC compressor, it's going to go on like this. I'm going to hold that for me. It's going to go on like this. Now when the AC compressor goes on, it still is real tight up against the engine, and you do have to do some bending of the lines. And these lines are aluminum, and they will crack if you're not careful. But as we start to put this together, we'll take a look at it, and you just want to be careful careful with it. Okay, when you're putting the AC compressor on here, when you have the extra lugs, the extra mounting lugs, sometimes you have to trim one off. Especially if you have 4 of them, you're going to have to trim one off because it's going to interfere with the cradle. Now on this particular one, if we were mounting the AC compressor in this position, we'd have to trim this lug off. But we're not mounting it in this position because the lines don't indicate. We're going to rotate it back 1/4 of a turn, and we're going to end up mounting it in this position. Hold on just a second. And the way you determine that is by getting back here and looking at those lines and figuring out what the best orientation is for the lines themselves when they come into the back end of this. Now, we figured that this orientation right now would put the lines coming in about like this. And that is going to require that we do some bending of the lines to clear this mount. But now you can see why we didn't mount this mount vertically, is because then there'd be absolutely no room. At least with the way we got it mounted now, we can bend the line up a little bit to clear. Now, one more thing is the AC compressor is mounted, and there's a spacer behind the mounting bracket. Now, there's, like I said before, several different distances between the mounting flanges and the pulley. And on the Fieros, there's like 3 or 4 different setups. And so these blocks are going to be different thickness depending upon which setup you have on here. So that's something to keep in mind. You may have to use narrower blocks or wider blocks. That's why we don't just have a bracket that just goes back and bolts up to the engine, because it won't necessarily handle every AC compressor that Fiero had. Okay, we have the AC compressor mounted. We've got the belt lined up, and again the spacers behind this bracket control your alignment of your belt. And as you can see, it's bolted on here. We got the brackets bolted on up here, and then we have 2 screws coming through the back of the AC compressor mounting this. And then we're going to come around here in the back, and we can see the AC lines are headed all the way over here. Now these lines will turn a little bit, and we'll show you how they attach to the stock Fiero lines. They've been bent just a little bit back in here to clear the mount. And then we put a angle bracket back here to hold the tail end of the AC compressor. And we got that all mounted. We're working on the alternator mount right now. And we'll show you that in just a second. This is our new alternator bracket. It bolts right up to the end of the cylinder head using these 2 holes and this hole. I'm going to stick it on there real quick. Just so we can talk about it. And then we're putting on a belt tensioner. The belt tensioner is going to mount right in this area. And it'll put tension on all the belts, and then we're going to start putting this together. This is where we start. All right, this is the alternator bracket with the belt tensioner attached to it, and it's held on with an Allen head cap screw and a large washer on this side, and it goes through onto the other side with a nut that's going to be tightened down on it real tight. Up in here, this nut goes into this recess here. And the nut sometimes, depending on the block, the casting, sometimes that nut is real close to the surface of the underside of this flange for where the head bolts on. And in that case, so when you're putting this bracket on, you just want to watch and make sure where it's hitting. Sometimes you have to index this nut so that the flat corresponds with the flat area that it's coming up close against. A little note on the alternator mounting we found on this engine. Never noticed this before. It hasn't happened on any other engines, but when we go to put the alternator bracket up against here flat, we always make sure brackets are mounted flat and square, especially, you know, for an alternator or AC compressor or something. When you, on this engine, if you run your finger down here at the bottom end of the cylinder head, you can feel that the head gasket is sticking out ever so slightly. And I mean only about 2 or 3 or 4 thousandths. But that's when you put the bracket up on here, it's without tightening it down tight. I imagine we could push it in by tightening it down tight. We don't want to do that. So we're going to take just a little and just grind the edge of this gasket so it doesn't stick out past the cylinder head, because it's hitting the backside of the alternator bracket. And that's just a note. It's the first time I've seen it, and we've done a lot of LS swaps, and first time we've noticed it. And like I said, when we put the alternator bracket up to the cylinder head, you know, and start to bolt it down, we always look around here behind it, make sure it's fitting flush. And when we were starting to stick the other one on, it was out just a little bit at the bottom. You know, you could see a little bit of a gap. So we're fixing that. Just something to keep an eye out for. Okay, we have the alternator bracket on, and we're about to mount the alternator. You can see the belt tensioner. We're going to be watching the alternator and the belt tensioner and everything else right through here to make sure they're all on the same line. And so far they are. AC compressor, belt tensioner, and harmonic balancer pulley are all on the same line. We'll be putting the alternator up on there. The harmonic balancer pulley and the stock Bureau AC compressor pulley, when you're using the serpentine pulley, they both use a 6-groove wide serpentine belt. The Fiero alternator, when you go to, if your Fiero alternator has a serpentine pulley on it, it's only a 5-groove pulley, so you have to grab another pulley. You can get it from AutoZone or any place like that for a 6-groove pulley. You know, just buy one for a Camaro or something. Any GM product that has a 6-groove, they're all the same basically. But we're going to put the alternator on here. We've just changed the pulley on the front of it to the 6-groove pulley. This isn't the pulley that was on it originally. We just put that one on. The original pulley was 1 groove short. And we'll be putting the alternator on just kind of like this. And then we have another spacer here that's going to go in behind here. And this spacer is 1.15 inches long. It's got a hole through it. Okay, we're going to put the alternator on now. And you'll notice that it's a 6-groove wide pulley. And we have a spacer that we're using back behind the alternator down in this area. And the spacer is 1.15 inches long. It's got a hole through it, made out of aluminum. And we'll put a bolt through it and bolt this thing on. Okay, after we bolted the alternator on, we got the idler pulley and everything else on, so we put the belt on. And this is how it looks. And the important thing is about getting all the belts in line. We've already checked all these. They're perfectly in line. You want to double check it and whenever you put it together. It's always a good idea, because if they're in line now, or if they have to be out of line now, now's the time to fix it, not after it gets in the car, because it's kind of hard to get to some of these. When you are trying to replace the belt in the car, though, you can get to it. It isn't that bad, but you're not going to be replacing pulleys in the car very easily. You know, if you have to replace a pulley or remount something to get the belt lined up, it's going to be a lot easier to do it out here. So you're eyeballing it really close and putting a straight edge along, like on the face of this harmonic balancer pulley out to the face of this pulley here, making sure the belt runs parallel to that space, you know, through to here. And you're doing the same thing, or eyeballing it really close all the way around. Okay, now that we got that on there, we also have, we're going on to the next topic, these fittings for our electric water pump. Remember I was telling you early on in the tape that the fitting over here in the lower left needs to have an elbow on it because it's really close to the shock tower on the 88 car. On the earlier cars, it's not so bad. And so we got an elbow on here, and we have a 3/4 inch hose barb on here, hose barb here, and another one here. And we have these bolted up to the block and bolted up tight with the 3 bolts each. Just since we're done, we pretty much got the everything done on this that we can do before we put it in the car. So I'm going to take a real slow walk around, look at everything with the light, in case you've missed any details so far. Rob points out something here that I hadn't thought of. It's a pretty good idea to point it out to you. Right in this area we have the wire harness for the crank sensor, and I'm sorry, cam sensor. And on the GM, if you're using the GM harness, you can leave this all on here, right down here, and the harness plugs in right down at the bottom of this plug. If you're using a wiring harness like from Street and Performance, you can take this out and unplug it right here, because the Street and Performance wiring harness plugs in right here. It's easier to take this out now than after you get it in the car. So if you're, like I said, if you're using the aftermarket harness, some of the aftermarket harnesses plug in right here, and then the GM harness and maybe some of the other aftermarket harnesses plug in down here. So you can either take this piece out or leave it in, depending on what harness you're using. And then we're going to just take a real slow walk around looking at stuff that may not have shown real well in our video. Some of the lighting wasn't that great. This is our front mount on the rear side of the engine. Let's see, let's go over here. I know we didn't have a good picture of this mount here, but it's pretty simple. Let me show you a little detail. And this mount here is bolted on. Is it dusty? Okay, we've rolled the whole engine cradle assembly up underneath the car, and we're just about ready to put it in for the last time. Don't know what else I can show you, so we're going to put it in. When you're lifting the engine cradle assembly up into the car, you want to have your chain adjusted so that the front 2 ears for the horizontal bolts, they're a little bit higher than the rear of it as it goes up in there. And as you get it up in there, then you put the bolts in, just slide the bolts in for the front horizontal bolts, and then you can just bring the back end of it up in there. This thing only took about 4 seconds to put in the car. And it's getting ready to tighten up the bolts on the rear of the cradle, and we got her in there. Got to put the nuts, of course, on the front bolts, but other than that, it's in there. It's in there for the last time. Okay, we have the engine up in there. It's bolted in all the way. All the cradle bolts are in, and we got the A-frame out of the way. We're going to put the suspension back together the same way it came apart, and we're going to put the handbrake cables in, and then we're going to set this on the floor. Our goal is to start building the exhaust system as soon as we can, because it's going to be sent out for HTP coating, and that'll take a few days, and we can work on a bunch of the other stuff while that's gone. So we're hoping to start building the exhaust system pretty soon. We may do a few other things before we do the exhaust, and but we'll keep track of it. But the suspension's going to go back on now, and the handbrake cables are going to go back in, and that kind of stuff. The reason the LS1 kit that uses stock Fierro transmission, the reason I'm supplying the right side axle is because we make this thing up special to clear the larger ring gear. It's got a stock outboard Fierro CV joint on it. It's got a stock Fierro right side axle shaft assembly, but this end of it is this is custom configured so that it'll fit in there and clear the ring gear. I'm about to post two pictures. One of them before and after. There's a small boss on the side of the LS engine that we didn't trim off when the thing was outside the car. I forgot to, so we just trimmed it off in the car. And I'll post those two pictures up right after this video. And then I'll show you a little bit of what it looks like in the car. Alright, this is how it looks when the axle's in. The shaft clears the flywheel. This is all being done because of the diameter of the flywheel. And you can see up there where the block is that we trimmed off right up in here. And it clears the axle and the boot and boot clamp and everything else. And if I wasn't getting my own shadow, you could see the clearance on the ring gear. That it clears the axle shaft, or it clears the inboard tripod. That's it. Okay, what we're dealing with right here is electronic throttle pedal. On the later model LS2s, all the LS3s, 376s, and LS7s, and some LS6s, you have to use electronic throttle pedal. On the LS6s, you can't use this pedal, but on all the others, the LS2, the electronic LS2s, the LS3s, LS376, and the LS7s, you need to put an electronic gas pedal in, and this would be the one we use. If you're buying the harness, the wiring harness directly from GM, this isn't the one that comes with that wire harness kit from GM, but it's the one we like to use. The one that comes with the wire harness kit from GM is a truck gas pedal. It's huge. This is the one we use. It's GM part number 25835421. And this bracket is one we make to mount the gas pedal into the car. It goes right up where the old gas pedal used to mount, and you just mount the gas pedal to it and then put it in. So let's go take a look at the old gas pedal. Okay, this is the stock Fierro gas pedal still in the car. You can take out these two screws right here, and that loosens up the gas pedal, and then the lever that's attached to the gas pedal goes up over the console and then down into the middle of the tunnel here between the seats, and the cable attaches down there. And you can take out that throttle cable, the whole throttle cable, the pedal, and everything, because you're not going to be able to use them. Don't throw away the cable, because they're kind of rare. They're not being made anymore. And the cable runs down through the center and into the engine compartment, and you can just pull it all out from this end. There is a bracket that's up underneath the radio that one end of the cable snaps into. That's kind of hard to reach, but it's worth taking it out. You know, you got to take it all out anyway. And then the bracket that we were just showing you mounts in there this side up to using these same two screws down here by my thumb, and it mounts the gas pedal in there, same place where it used to be. You can't hardly tell it's just different once you start driving it. So you have to put electronic gas pedal in if you're doing an LS engine with an electronic throttle body. Okay, here's what the finished gas pedal looks like. And it turns out in the right place. That's why I use that particular part number, is because the part number that comes with the GM wiring harness is like a truck pedal compared to this thing. It's a lot longer arm on it. And the wiring's the same, so it don't matter. Okay, we're also going to be changing the radiator in this car. It's pretty simple to swap. You just take off, of course you want to drain it, take off the top and bottom radiator hoses and remove the fan and fan shroud for now. You're going to be reusing the hoses and the fan shroud. If you got AC lines, you're going to remove the AC lines from the radiator. Again, you'll be reusing those. And then the radiator comes right on up out of there. Sometimes it's easier to do it with the hood off. If you have the hood off, you want to do it when you got the hood off. Otherwise, you can do it without taking the hood off. And you just basically put the radiator back in with the same fasteners and everything else that you take the old one out with. I have some still photos that I'm going to insert into the video in this area, showing the instructions that I have for the mounting the radiators nowadays. And then right behind me I have an LS3 car that we've already changed the radiator on. This is a little bit dustier, but as you can see, it's an aluminum radiator. You can see the aluminum cores in here, but it basically looks just like the car we just looked at, except that this one is a little dustier. And the radiator will fit right down in there, right where the stock radiator was. And in this area here, there's a little bit of trimming around the bracket that's around this gooseneck, because the aluminum radiator has welded aluminum tanks, and they're a little more square than the rounded tanks from a stock fuel, or the rounded tanks that we used to have on our brass copper radiators. Just a little in process on the radiator installation. We have to open this up just a little bit around here, and I'm putting in, like I said, I'm putting in some still photos of the installation that I'm already sending out with the radiators, and I thought I'd give you a live shot too. Okay, so here we go. Got the radiator in. Everything else put back together up front here. Okay, on the car that's been the subject car of our video so far, the red car, he wants to mount his battery back in the back, but typically we mount the battery up front, so we're looking at the other LSx V car right now. And the battery tray just mounts right into the plastic liner of the front compartment here, and the top edge of the battery tray is about equal with the top edge of this plastic liner. And then you just cut out a hole big enough for the battery box to set into and center it left to right in the car and have the top edge just right along the top edge here. And then on the battery tray, if you look real close, the vertical side here and the flat floor, the one side's longer than the other one, and the longer one is the flat floor. So when you put it in, to eyeball it and figure out which one's the longer surface, and the longer surface is the one that goes down. It has this little bump in here to clear the sway bar when the car's got 84 through 87 sway bars. And we also bring the cables in. We bring the negative cable in on the right-hand side of the car so we can crisscross the cables, so we can, if you need to, when you're hooking the battery up or whatever, you can slide the battery back. And then once you get your cables hooked up, it'll slide right forward and it'll bump against that little sway bar clearance notch in there, and that'll keep the battery from going up against the wall and putting the terminals up against the wall. It's a fiberglass tray. It ain't going to hurt putting the terminals up there, but you can damage the terminals if the battery bangs against there or is clamped against there. And typically, we use the spare tire to hold the battery in. You can, if you're not running a spare tire or you've got wheels or brakes or whatever on the car that mean that you can't use a spare tire, then you can just stop at AutoZone or whatever and pick up one of the bar clamps to put over the top of the battery. Okay. Okay, this is the fitting for the oil pressure sending unit that's going to screw into that oil pressure bung that we changed on the Valley right at the first part of the video. This 90-degree fitting will screw into there. This has to be assembled on the engine. I'm not showing you it on the engine yet because it's not on the engine, but we're using oil pressure sending unit, and this is where the Furo wiring harness will plug in and still operate the Furo sending unit, the Furo gauge. We have a reducer we made here, and we're using the oil pressure sending unit from the LSx V that we took out of the intake manifold on the LSx V. And I'll show you a shot of this thing once it's on the engine all put together. Okay, this is the oil pressure sending configuration on the engine. There's a 90-degree angle that's screwing into the fitting we had in there before, and then there's a adapter fitting, and coming towards us is the oil pressure sending unit for the Furo gauge, and then off to the left end of it is the oil pressure sending unit for the ECM on the LSx V. I'm showing it to you now because once we put the throttle body on, it's really hard to see it back in there. Okay, this is the driver's side water pipe. Notice that it's bent. And this is the passenger side water pipe. Notice that it's also bent. Typically, when we're doing these swaps, we trim these pipes back a little bit and put our hoses on. So we'll be putting our hoses on up forward of these pipes, so we're going to be able to cut the bends out. But even on a really nice car, a lot of times the pipes will be bent. More often than not, they'll be bent. But we'll be trimming these back and for our cooling system hoses. Okay, right now we're looking at the LS3, the other LS3 swap we have going on. We're about to start doing the cooling system on the subject car, so I thought I'd show you where we're headed. We use, as you probably know by now, we use an electric water pump. And the electric water pump, I'm going to give a lot more detail in a few minutes, but I'm just giving you a brush over the top right now. Electric water pump mounts down there to see the red thing. And then up here we use, because the water pump, the original water pump had the gooseneck or all the hose connections in it, we use what we call a thermostat housing block. And the thermostat housing block is this item you see in front of it. We use a billet aluminum gooseneck on top of the thermostat housing block. And we do it because we have to drill and tap a pipe thread hole to hook up this black hose to it, to put a fitting in to hook up this black hose to it. The hose goes over to the water pipe that's in the area of the valley cover. Try to show you a better picture of that here in a sec. Right now we're looking again at our subject car. And you see this pipe coming out right here. It has a crossover and it connects to the cylinder heads, and that's to let the steam off the cylinder heads, or help circulate the water in the cylinder heads. And that's the fitting. From this fitting here, we go over into that gooseneck that I was just showing you on the other car. Now this is one of the billet aluminum goosenecks. The reason we're using a billet aluminum one is because the housing has more thickness to it, so that we can drill it and tap it, so that we can put in one of these little hose barb fittings, 1/8 inch pipe thread at one end and a hose barb at the other end. And we can drill it through this housing and still have enough service to put some threads in it and thread it into the housing. This is the billet aluminum thermostat housing block that I was talking about. It's got a little lip in here, and you set your thermostat down in there and then put that gooseneck right on top. And then it's got fittings around the perimeter here, around the outside for our hoses. Now we're going to explain all the hoses and show you all the routing and everything as we go. Right now, in the engine block, there's no provision for the stock Bureau water temperature sensor, so that, for using the stock Bureau water temperature sensor, and that way you can use the stock Bureau water temperature gauge. So what we're going to do in this thermostat housing block is down in the bottom of this, underneath, we're going to drill a hole and tap it for a 3/8 pipe tap, and we're going to put the water temperature sending unit right in the bottom of this. You'll notice on the LS engine by now, you've noticed by now, that there's no national pipe thread fittings in there, so you can't put in a regular threaded temperature sensor into any place on that engine block because there's no NPT threads in the block. And then also on this particular car, we're going to set up a second water temperature sensor switch that connects at a higher temperature. In the like 220, 230 range. And we're going to also put that hole in the bottom of this. In other words, we're going to put two holes in it and thread them from this side. And the second water temperature sending unit, we're hoping will will provide a idiot light. We're going to hook it up to an idiot light, hook it up to ground through an idiot light on the dashboard, so that if something goes wrong with the water pump, it stops working, or there's something like that happens, like blow a fuse or something, which isn't a common thing. We haven't had that happening, but this customer doesn't read his gauges very often, and he says so he needs a little light to go on when he better be glancing at his gauges, kind of something to warn him. And so we're going to put a water temperature sensor in here that's got about a 230 turn-on point or something like that, just so it'll light up an idiot light on his dash and say, hey, take a look at the gauges. So we're going to try that out on this car and see how well that works. It doesn't sound like all that bad of an idea. This is the electric water pump we're going to be using. It's a CSI 925R, and R means red. And you can get these in silver and black also. And plumbing fittings, we've already started putting in some of the plumbing fittings. We still have we need a 90-degree half-inch street elbow on this end of the pump. But we're going to show you where this mounts in there and what directions we're going with it, with all the hoses and where they got to connect to and everything. We're going to get real detailed about it. So not a big deal. This piece is just giving you a heads up that what she looks like to start out with. So you're going to see a lot more of these three different parts, but I thought I'd give you a little introduction to them. And you'll be seeing them, and we'll be talking a lot more detail further on in the video. Okay, what we're looking at is Rob's got pretty much figured out how these pumps mount. And you can see my hand here. He has trimmed from this hole that's along here. He has trimmed down here and then put a radius into here and then up this side here to meet that hole. And this will be where a bunch of the hoses and stuff are going to be going through. And he's got some rubber edging that he's going to put around the hole so there's not a sharp edge. But that'll get the clearance for the hoses and stuff. They're going to be running to the water pump. Water pump's going to be mounted up in that area. And we'll show you more as we go. Okay, so this is the configuration of the water pump before we put it in. We're going to mount it with the lettering up, the inlet pipe for the hose that's the hose coming from the radiator. The right side water pipe will be leading to this fitting. And we are going to mount it against that bulkhead we showed you before. And these are the fittings, the way we configure the fittings. On this end we use a reducer, take it down to half-inch, then use a half-inch street elbow with this 3/4-inch hose barb. On this end here we use a 3/8 or 3/4 nipple, a reducing 90-degree turn, and then another hose barb. And that's how it sets up in the car. Now we're going to set it to get up close to the car and show you where it's going to bolt in. If you turn this over, there's three bolt holes on the back, and we're going to mount it right up against that bulkhead in the car, where the battery used to sit. And we've already drilled 3 holes to match these 3 holes, and the bolts will come through to keep from having any vibration when the thing's running. We're going to put a little bit of cushioning tape on this side of the pump when we put it in for the last time, just to keep it from any possibility of vibration. Right with you. Okay, we're getting ready to mount the water pump, or I'm going to show you how the water pump mounts. We're not actually putting it in right this second. We got to. I'm just videotaping this. The pump is going to go in. There's 3 holes down there, and the pump's going to go in and mount right about in this area, this spot, and it'll be bolted in next time you see it. Over on the far side, you see the pipes that we talked about in the last little segment. The pipe on the far side is further away because we have a water pipe that's going to drop down through that hole that we got in the bottom of the battery, or in the bottom of the area. We have a pipe that's going to be dropping down through there, part of the rest of the cooling system. So Rob spaces that out a little bit so that the pipe will pass through that area. Okay, we have the water pump mounted, and it's bolted in through the bulkhead on the back side here, where you see my hand. It's bolted on through here. And then we're going to show you some of the hoses around here. We'll probably cover a lot of these topics, more than once. But this hose here, this is the small diameter hose from the heater core. That's the water coming back from the heater core. This hose will be connecting to one of the fittings on our junction block, on our thermostat housing block. We'll be talking about that in a minute. This pipe that we have coming up through here, this is an 1.5 inch pipe, and there's going to be a hose connected to that, and that pipe is the one that's going to be going to the gooseneck that's on the thermostat housing block. Now, we're going to go look in the wheel well so you can see where it goes down there. Okay, on this side here, down in the wheel well, you can see that we put a round plate or any kind of plate on here where these 3 bolts are holding the water pump on. That just squeezes the water pump to this metal chassis here, and we assume it'll cut down on vibration or anything, so we do it and just did it for that purpose. The hose that we saw, or the pipe that we saw up on top, that's the one that's going to the gooseneck, and it's coming down and then under the engine cradle and across to the other side of the car. That's this one here, and that's the one that's going to the top radiator hose up front. It'll use the driver's side water pipe. This pipe is another 1.5-inch piece of pipe, and it's got about a 45-degree bend down here where it connects to the right side water pipe, and it also has a 3/4-inch radiator hose bung welded in right in here, and that's welded in because we ended up having to cut off the bent water pipe, and some Fieros don't even have that hose fitting on the water pipe anyway, so on the original water pipe. Some of the earlier Fieros don't have that, and so you'll have to put a fitting in, a 3/4-inch hose barb fitting here, and this will be the other heater hose, the 3/4-inch heater core hose that goes up towards the heater core will connect to that fitting there. That's the water coming back to the engine from. This is the water coming back to the engine from the heater core, and it'll connect here. And this pipe that's coming up here is the one that's going to feed water into the water pump. There's going to be a hose between these 2 fittings here. And that'll be the water coming back from the radiator into the engine. And then, of course, like I said before, this is the water coming out of the engine, headed over towards the left side of the car and then up to the radiator. Okay, we're under the car and we're over on the driver's side of the car. This water pipe is coming across the car. That's the one that's coming across with the water that's heading to the radiator, and it makes a 90-degree turn. And then we have a 1.5-inch straight piece of hose here that connects it into the stock water pipe. Stock water pipe is only 1.25 inches in diameter, so there's a sleeve that I sent along with the kit that fits inside this 1.5-inch hose and reduces it down to 1.25 inches. And the 1.25 inches is what the Fiero needs. We have that same type of connection over on the other side of the car where the 1.5-inch pipe, the one that had that hose barb in, where that connects to the Fiero water pipe. And these 2 pipes, this piece of pipe here on this side and the one you see over there on the other side, they're just bent at a 90-degree angle, and then in the middle we have another piece of 1.5-inch radiator hose, straight hose that connects the 2 of them together. That allows you to index the pipes so that they're pointed in the right direction. If we could make that all one solid piece of pipe, but then it would be oversized package for shipping, and it wouldn't necessarily be indexed exactly the way you wanted. But this pipe here will get clamped to the engine cradle. Right now there's just a zip tie on it, but it's going to be getting clamped there. When we get up underneath the car to do the exhaust, we'll be doing that kind of stuff. Okay, we're showing you some more stuff here, which will probably be covered a couple of times. These fittings on the front of the engine. There's 2 of them on the left, 2 of them on the right. We talked about these fittings when we still had the engine out of the car. The top 2 fittings go to they'll be plumbed with hoses, and they'll go to the thermostat housing block, and the bottom 2 fittings will be plumbed over to the water pump. That'll be the connection between the engine and the water pump. And we'll be showing you more of that as we go. You also notice laying over here right now, just laying here on top of the alternator, this is the vacuum hose from the Fiero Power Brakes. that power brake line will be coming over and connecting to where this red plug is on the vacuum assist. That's where you pull your vacuum for your power brakes. So that'll be plumbing over here with a hose and be connecting there. We'll be showing you more of this as we go. We're going to look at the thermostat housing block now. Okay, here we're looking at the thermostat housing block. We've got two 3/4 inch hose barbs screwed into these two fittings, and a 1/2 inch hose barb screwed into this fitting. So that 1/2 inch hose barb, you can pretty much bet that's the hose that's going to be coming, that I showed you, that's coming from the heater core. That 1.5 inch hose is going to be going on to here. The two hoses, two fittings in the front of the engine that I identified as going to the thermostat housing block are going to be connecting to these two connections here. If we turn this around the side here, this is still can be adjusted, but here's where we put in that fitting that's going to that little pipe that connects the water outlets from the cylinder heads together. It's a cylinder crossover water pipe is what it is, or some people call it a steam pipe. And then, so that's in here, and it's been tapped in. And then we're going to look at the other side of this. Let's see here. Let me turn this over. And we have the Fiero water temperature sending unit. Like I said before, there's no NPT pipe threads in the engine block or the cylinder heads of the LS engine. So we put this into the thermostat housing block. And then we also have a water temperature sensor from the old engine. This, what was it, like 230 degrees or so, this thing completes the circuit. It goes to ground. And that's the one we're going to use to wire up the dashboard light that warns of temperatures high. So the radiator fan turn on that's in the wiring harness is typically like 205 or something like that is when the radiator fan turns on. And then this sensor here is approximately 230, 232 degree turn on. So that'll light up a light if for some reason the water temperature is getting higher than what the radiator fan typically keeps it. It'll all work out. Okay, all the hoses and everything else in this corner over here is all going to be layered on top of each other, so we're going to try to show you layer by layer, I guess. The bottom fitting over on my left here is one of the fittings that the two bottom fittings together, they both go over to the water pump. The one on my bottom left is going over here to the water pump, right over here on this end of the water pump. And the one on my right is going to the other end of the water pump. Those fittings are all on and screwed on and all ready to go. We're building this layer by layer, so we'll be looking in here again yet. Okay, over here in the wheel well, we have this hose on for our right side water pipe that connects it to the water pump. And we also have the heater hose. It's kind of hard to see down in there, but we have the heater hose, 3/4 inch heater hose fitting connected to that hose barb down there. Okay, it's time for a little correction. This 3/4 inch heater hose that's connected to this pipe here, I had previously identified as a hose coming back from the heater core, and that is correct. However, I incorrectly identified this hose. This is a 5/8 hose. I had identified it as 1/2 inch before. It's a 5/8 hose, and this is water going to the heater core. It's coming. It connects to the thermostat housing block just under the thermostat, and it's water that's being circulated into the heater core, just like it would on normal engine from below the thermostat. I had identified both of these hoses, this 5/8 and the one underneath the 3/4. I had identified previously both of those hoses coming from the heater core. That don't work. One of them's got to be going to, and the other one's got to be coming from. This is the one going to. The one down there in the wheel well is the one coming from. Okay, here, this is the thermostat housing block again, and on the back of it there's two threaded holes in it. And this is a bracket we made that'll bolt to the cylinder head, bolt this onto the forward cylinder head, and it's a bracket that's bolted onto the thermostat housing block and allows the block to be bolted to the cylinder head, so it's got a nice stable mounting. Okay, we've mounted the thermostat housing block, and right over here we connected that 5/8 hose coming from the heater core. We connected it to this fitting here, and then over here on this side we have that 3/4 inch fitting. And I can move that out of the way yet because we haven't put that on yet. This hose here comes down and around this way and to the top fitting on these water fittings coming out of front, comes over to the top fitting here on my right. And then this hose coming off here goes over to the top fitting over here on my left. And as far as the cooling system is still concerned, really all we have to do now is hook up this hose to this pipe, or this gooseneck to the pipe, and also hook up this fitting here, this hose barb, and it's going to run right here to this pipe here. A couple other things we did here before we put on the thermostat housing block is we connected the vacuum line for the brakes. You'll recall the vacuum line. You can see it in there, but I can't reach in there to point at it. But that's the vacuum line for the power brakes, and we took a piece of we extended that over and put a U-turn on it and plumbed it right here to this fitting on the back of the intake manifold. And also, you'll remember this corrugated hose that was coming out of this, that attaches this breather. This hose comes with the engine, but you usually find it on the other end of the engine down by the throttle body, and it connects before the intake manifold's turned around. This hose connects right here and just comes right around and connects just behind the throttle body on the intake. Well, the throttle body on the intake is at the other end of the engine now. So what we've done is we take that same hose that comes with the engine and snap it onto the same fitting, and then it goes into this pipe. This pipe, I'll explain in a second, makes a turn here, goes along the right over here by just to the right of the injectors, in my view, and it goes all the way down along that way, and then at the other end of the engine, way down here, it makes a turn to go into that fitting that's on the plastic intake manifold behind the throttle body. That piece of pipe that we use right there is one of the pieces that comes when we furnish the master build kit, and it's a Dorman part number 800-155. You can get it at any parts store, and it's got the correct snap fittings for this type of fitting here, and makes it so you don't have to put some kind of hose on there. You already got a nice hose to put on there that snaps on, and we just take that piece and bend it, and then cut off one end of it and put a hose clamp on it. Okay, we got the hose on the gooseneck, and virtually everything's finished up right in this area except for tightening a couple hose clamps, and that top clamp we won't put on until after we put water in it anyway. Now we're going to get the car up on the lift, and we got it down on all four wheels, and we just put it up on the lift, and we're going to take it up in the air and start working underneath the car. Okay, we're working on the exhaust on the car. This is all 2.5-inch exhaust. We got some spun caps and some turbo type mufflers, and we've taken a little bit out of the trunk floor. We'll look at that when we get up on the top. But this exhaust is not the exhaust that comes with the kit when I send it to you, because it's, as you can see, it's a bunch of pieces that are welded together, a bunch of mandrel bent tubes, and it's just impossible to build this if you don't have the car here. I'm going to follow the routing of the pipes for you. The header, this is on the forward side of the engine. The header's up there, and the collector has already has an O2 sensor bung in it. And then we're coming down and making the turn under the oil pan. We have a cat. And this pipe goes up. And I'm going to come over here on this side. Pipe goes up and then makes a turn towards me, towards the top of the photo, into a muffler, which you can't see from here. So hang on a second, let me get you over here. Into this muffler. And the muffler goes on across this pipe. And then modified resonator tip. And then the other exhaust, we're going to come back over here. Comes off the rear header, comes down and makes a turn under the cradle, and then a turn to the driver's side of the car. We got a cat. We'll slip underneath here. And from the cat we have a U-bend, and then the muffler, and then a little bit of piping to the tip. The tips, you have to modify them to use them, because the tips are longer. They go way out back here, so they have to be cut off and welded onto the pipe. And then, of course, we try to get the tips to match side to side, all that kind of stuff. This exhaust is a true dual system. There's no crossover pipe or H-pipe type thing on this car, and on the last couple of them we've done. Using a bigger exhaust system, we're going to put a H-pipe in, and it's going to go from about here. It's going to come over here and then come down and join up to this pipe. That'll tie the two pipes together in front of the cat. We'll be coming from over here in front of this cat over to over here, which is in front of this cat. And we'll show you that. Well, we thought we'd show it to you without the crossover, and then we'll show you that when it's done. We still have to take it off, do some welding and stuff to it, but we'll be putting a crossover on it first. I took several pictures of this same exhaust system, and I'm going to put those in this video also, still pictures, so you can see any detail you might be looking for. Okay, so now we've added the H-pipe, if you will. Like I said, it's coming out from the down pipe from the front side manifold, or front side header, and it's cutting out before you get to the cat, and then it's coming over here and joining up with the other pipe before you get to the cat. I'll get some good pictures of this exhaust system and video of it when we take it off to finish all the welding and grind the welds and stuff, because we're going to take it out and send this out to get it plated. And then we'll put her back on once it's plated. On this car, the exhaust system is, you saw a video of it earlier, and to do that type of exhaust system, you have to take the floor out of the trunk and shallow the trunk out a little bit. So we're shallowing it to this level here, and making a plate to go in there. You can see how much of it we cut out, and then the new plate will be going right on top of this lip here. There's our new steel trunk floor, and we got sealant around the edges, and of course we'll paint it. Okay, we're looking at the cooling system again, the tubing and stuff for the cooling system. You'll recall this is the return hose from the heater core that feeds into the pipe that leads up into the water pump. And we've made a clamp for the crossover pipe. Remember, we had that zip tied up. And then over here on this end, also made another clamp for it. This piece will be coming off and getting painted, make it pretty. And remember, we talked about the rubber hose that joins the 1.25" Fiero pipe to the 1.5" water crossover pipe. There's a sleeve slides up inside right here, and that's a reducer for the piece of 1.5" hose that we have there, joining the two of them together. The nice thing about this is we're cut back far enough on this Fiero pipe that we got rid of those bends that we had in it earlier. A lot of Fieros have those bends. Even Fiero, real nice Fieros will have them because somebody jacked it up when they were servicing the car. You know, probably some car repair guy. And bent the pipes because he thought they were structural somehow. Some thin piece of pipe is structural. And we have the AC lines on. And let's see, here we'll come over here on this side. AC lines are coming across. And then they will join up. Right now they're just loose on here. But then we've taken the Fiero AC lines, which are right here, and we've taken them loose from the bulkhead over here on the side, and bent them just slightly towards the center of the car, and they'll be joining up. Get the light here. They'll be joining up right over in this area here. The Fiero lines will turn, and they turn on these circles. They'll connect right here to the AC lines up. Okay, what we've got here, we got the gas tank out. You got to take the gas tank out of your Fiero if you're going to do a LS swap, because you have to change the fuel pump. The fuel pump, even from a V6 Fiero, isn't going to handle the needs of an LS engine. So you take the pump out. Take the pump out right here. Just turn this collar, lift the thing out, put a new fuel pump on it. The pump that I use is an EP242. That's a Delco part number. It's listed as one of the applications for that part number is Buick Grand National, and anybody should be able to cross-reference that EP242 number. And anyway, we take it out and change the fuel pump if it needs it. Anyway, while you have the tank out doing a fuel pump change, we also use braided fuel lines on all the LS engines, and they have to connect back here, and we typically use the Edelbrock high pressure hose number 63206, and there's 6 feet of it. Of course, you don't need all 6 feet for and you can see that we have it looped around. We just have it one end of each end of the hose connected to inlet and return line, or in and out lines on the fuel pump. Right now it's just in a loop. When we get it up in there and start getting our lines hooked up, we'll cut this loop and take out what we don't need. We'll take out the piece we don't need and put the correct fittings and stuff on it. Okay, got the gas tank back in, got the lines back up. When we put in when we mount the battery up front, we run our battery cables along either side of the gas tank through here, down along either side of the gas tank, and then route them up. This car is not getting the battery mounted up front, so we haven't routed the cables on this car yet, or we won't be routing them on this car. And we're working on the fuel system, and we've got, I'm going to move it, hang and get the light over here. Those braided hoses I showed you earlier. One of them, of course, is the return, and one of them is the feed line. As we look up in here, the larger fuel line, the one that's connected to the larger fuel line, is going through the bulkhead here, and then it's going up to the fuel filter. Now, this fuel filter is a return fuel filter. The fuel returns to the gas tank right here. It doesn't go, the feed line on the injectors up top doesn't have a regulator on it, and it doesn't have a return line. And that's because we're using a 99 Corvette fuel filter, and the 99 fuel filter has the regulator internal, and it does a return deal right here. So the fuel line coming from the larger 3/8 diameter hose is the fuel line coming in on this side, one coming over on the side, and then out the other end we will have, right now it's capped off, but we will have the fuel line that goes up to the fuel rails coming out of the other end, and then the bypass, in other words, the fuel returning to the gas tank is coming out of this center fitting and going to the 5/16 line that's on the gas tank. Now, so this is the loop that I showed you before. This is the loop, and we brought it down here and cut off the lines and made our connection right here. Okay, so we're working on finishing up the fuel system. You can see the filter down there, and the line coming out of this end of it, the left end of it, and the line, this cable that's in the way is the shift cable. This is the shift cable. Here's where your line is coming out of the fuel filter, and it's going up the bulkhead here. We use one of those Dorman part numbers that I was telling you about before, and bent the line to go in and hug the bulkhead, and then we come up the bulkhead here and use one of our fittings to make the turn into the fuel rails. Now, there's one of these fittings at each end of the pipe, of course, because right here, the blue fitting that you can see, that was the fitting that attached the other end of that Dorman shaft that has the fuel petcocks at each end, part number 800155. That's what that fuel line is right there, and then the Russell fittings will connect to it, and it comes up right here. Okay, so we're getting ready to do the wiring harness. We're doing an LS3 swap into an 88 Furo GT, and this is the 88 Furo GT wiring harness. First thing we're going to do is modify this to accept the Street and Performance wiring harness that we're using for our swap. So what we've done is we've hung this wiring harness up on a board. You don't really have to hang it up on a board. We're hanging it up on the board so that we can explain the harness and exactly what we're doing with all the wires, and it's laid out in some kind of positioning so that you can actually relate to it. So right now we're going to go through the wiring harness and take off all of the insulation or all of the intestine covers, and hang it, and it'll be hanging on this board, and we'll go through all the wires, explain what they do, and which ones are needed, which ones aren't needed to join up with the other harness. Okay, we got the intestines off, and we have the harness hanging from our board up here. What we're going to do is we're going to try to cover this in a couple of groups. We're going to start here at the bulkhead pass-through piece and start working our way down this direction. The first two wires we come to are a purple with a white stripe and a yellow wire. These go to your these go to your VSS sender, your vehicle speed sensor, that's on the transmission, and of course we'll keep those because we're still using the same transmission. And then these two wires are this one wire going down into this plug deal. These are for your AC compressor, and then we're keeping the AC compressor, so we're keeping those wires. Going off this direction, this ground wire is just inside the loop, and it goes down here, and it's a ground wire here too. So when you take this apart, that ground wire is going to be eliminated. Over here to the relays that are on these are the relays that are on the bulkhead right behind the driver on the engine side. This top one is for the original fuel pressure relay or fuel pump relay, and then this is for the AC relay. The AC relay has greens and blues in it, and relay for the fuel pressure has I like to call them earth tones. Anyway, this will be eliminated. The one for the fuel pump relay, that'll be eliminated because that's controlled by the new ECM. And when we take these wires out, we're actually going to go take them out all the way through this plug, because we're going to be dealing with the rest of this harness up here towards the top in a few minutes. But we'll be removing this fitting that goes through the bulkhead, and we'll be taking those wires out all the way up to the connectors where they connect to the forward end of the car. And then, and of course, the AC relay we're keeping. Okay, next thing we're dealing with is these wires coming off here, a black and a brown wire going out here to this sensor right here. This is the air temperature sensor that was in the original Fiero air cleaner. That's going to be eliminated. That gets taken out. And then we come back up here, we have these wires coming off, a couple of browns and an orange with a black stripe. These go to the oil pressure sending unit, the plug for the oil pressure sending unit. And these are all going to get eliminated except for the center wire, the wire coming off the center right here. This is going to still plug into your original oil pressure sending unit, which is going to be mounted on the engine. And that wire has to be kept to operate the original Fiero oil pressure gauge. The other two wires and this plug will get eliminated and taken all the way back up through the harness, and we'll just keep this one wire. If you're not using the original Fiero oil pressure gauge, then you don't even need to keep this wire. Although it is handy for running your sensor into the gauge. You know, you can still use it for that, but you got to modify it, trace it down, and reconnect the other end of it to your gauge. Okay, and then coming down further on the harness, we have these grounds. This one heavy ground we talked about a few minutes ago, it'll be coming out as soon as the harness is taken apart. These two grounds we're going to keep, and they'll be connected to the engine block. Next thing down is the O2 sensor wire. It's a purple wire, a single prong plug. We're not using the original O2 sensor. The LSx V has O2 sensor. O2 sensors, and it has it built into the wiring harness, so this wire will be taken out. Okay, now we're dealing with, this is the plug that's on the right side inner wheel well area in the wiring harness, or in the car. It plugs into that unit over in the right side inner wheel well. And we're going to follow these wires down and talk about them. We're going to start out with this heavy purple one. The heavy purple wire goes down, and this is the wire that when you turn the key to the start position, it activates the starter. This is going to connect to the starter terminal on the solenoid. Also, we can cut off this wire headed down this way because this is just for the cold start injection on the old engine, so that'll be eliminated. But we're going to keep this purple wire. And then we'll get back up here, and we're going to go to this wire, a green with a white stripe. This is going to the air conditioning compressor. And since we're keeping the air conditioning compressor and the sensor that's inside the block that turns on the radiator fan, we're not going to be using that sensor to turn on the radiator fan. We'll talk about that in just a second. The other one goes to the AC compressor, and they're both tied together here. They're interchangeable between the two of them. We're going to keep one of them here and use it for the back end of the AC compressor. It plugs into the AC compressor. And the other one, we're going to take it off, and we're actually going to use the plug to connect to that sensor that was in the bottom of our thermostat housing block for the idiot light that was supposed to warn if the water temperature gets high. So we'll just use this plug on that, and when we put it in, when we wire it up, we'll show you. The next group of wires is I'm going to go over here to these. These are the wires that connect to the alternator, the heavy red wire. It also has two wires that go back and plug into this plug. And these wires go to your alternator. And of course we're keeping those because we're still using a pure alternator. And then right below this plug on the bulkhead is a terminal block with two threaded studs sticking out of it. And that's where this wire connects. So we'll be keeping all these. Let me put these up out of the way. All right, next set of wires coming out of this plug is a pink wire and a white wire, and they go to a light-colored gray plug that used to plug into your coil or your ignition system on the original engine. We're not going to use this plug. The white wire is a tack lead, and so we're going to keep the white wire in the harness because we're going to use it for our tack lead, and we'll show you how that's connected later. The pink wire is the hot with ignition on wire. Since our ECM is actually going to be controlling the ignition, we're using this wire is going to, on the ECM wiring harness, there's going to be a wire that's labeled hot with ignition on and in start. This pink wire is going to be the wire we use to connect to the new ECM, or the new harness, hot with ignition on and hot in start. So we'll be keeping that wire, and we're actually keeping both of them, but that's where they're going to connect. Next wire coming out of this plug is a green wire and a blue wire, and they're going down to the on the transmission for the backup light switch. And of course, we're still using the same transmission. We're going to use the same backup light switch. And then the one last wire here in this group is a water temperature sensor. This operates the fuel gauge. These are the wires that go to the fuel gauge. They're green. One of them's got like a yellow or almost yellow-white stripe, and the other one just solid green. And this connector. And since we're using the water temperature sensor, we took it out of the old engine. We put it into the bottom of the thermostat housing block. We'll be using this wire there. Okay, so the last group of wires coming down here is this big group here, and we just have it hanging down here in a batch because all these wires are getting eliminated from the harness. One of them is the cold start. It tells the engine that tells the original fuel ECM that the engine is cold, and it activates the cold start. It's a water temperature sensor is what it is, but they have several water temperature sensors in the old engines. And then we have another big old group of wires here that ran underneath the upper pendulum on the intake. One of them is for the IAC, and the other one is the throttle position sensor. They're not needed on the new engine. We've got those in the harness that comes with the engine. Next one is the map sensor plug. Typically these are green. I don't see them orange very often. I think 88's the only year they were orange, but it could be a green wire too. It's still got the same colors of wires going to it. Gray, green, and a black with a red stripe. This is also being eliminated since we're not using the original map sensor. The next group down here is this wire. This is going to the ignition module, and we're not using the original ignition module, so we're not using this wire either. Next one is the plug for the, you can say it out loud, I can't remember. EVAP. The EVAP. We're not using the EVAP, it's still on the original engine, so we're not needing this plug either. And then we have another one here. This is going to the injectors, and of course we're not using the injectors, so we're not needing these wires in this group either. And then one last plug is for the cold start injector, and once again we're not using that. So these wires will all get eliminated, and they'll get eliminated all the way back up to the plugs that are inside the car. Okay, we've got the wiring harness trimmed down. We cut off a bunch of wires and stuff, but first thing we did was we took this plug apart. It's not really a plug, it's just a pass-through that goes through the bulkhead, and we took it apart so that we could separate all these wires. There's still some glue and stuff retaining on these wires, but this plug just comes apart. And then we have these wires that we're eliminating. We cut them all off and tied them up into a bundle here, and also the wires going to the fuel pump relay. And these wires are all going to come back up through here, be eliminated through here. Most of them are going to these two black plugs that go to the ECM. Before we're done, we'll have eliminated these two plugs, and don't really need them because we don't have the ECM to plug them into. We're not using the original ECM. The only real tie-in between these wires that go to the original ECM and the rest of the harness is these three wires here that go to these two clear-colored plugs. And we'll be cutting these off down here for possible future use in some of the wiring we need to do for hooking up the other ECM. So we'll just cut them off here, and then as we hook them up or eliminate them, we'll let you know about that. The oil pressure sending unit that, the fuel pump relay wires that are coming up through here. A few of them are going to this connector, and we'll just cut them off back up in here, leave some length on them, and we're going to probably use a couple of them to run some connections through these plugs that go up towards the dashboard, just to make it a neater job. But that's what we'll do next, is we'll take these wires out of here and stuff and kind of show you what's left of the harness when we're done. Alright, we've got all our wires kind of like spread out here, but right now we're talking about this plug that's plugs into the original ECM. Most of the wires for that are the ones we had cut off, and they're being eliminated. There's a couple of other wires that go off in different directions. We're going to talk about each one of those. First of all, this blue wire, it goes off towards the air conditioner relay, and we're going to cut it off here. Later on, we'll be connecting this to a ground to operate the air conditioning when you push the button. This wire here, the black wire with the white stripe, is going to a common ground. So it can just be cut off, or just eliminate that, that lead to a ground, because we no longer need to ground the original ECM, because the original ECM isn't there. The orange wire is a power wire for the ECM. It's what boots up the ECM, constant power going to the ECM. And of course, we're not trying to constantly power the ECM, so that wire will be cut, if you look at it, it comes up here into this orange wire, and there's actually three connections here. And but we'll be eliminating the power to the ECM because we're not going to be powering the original ECM. And this one last wire, this brownish colored wire, it goes over to the ground plug that we talked about earlier in the original harness, that we were keeping this I terminal, but we don't need this ground, so we'll be cutting that off of here too. And that will eliminate this plug from our maze here. And then we'll come back and in a second, and we'll cover the other plug. Okay, now we're dealing with the other plug that went to the original ECM, and we're pretty much going to eliminate that. There's a few wires that are hanging down here that are among the ones that we had cut off earlier, and of course they're already eliminated. And then we have a few other wires coming out here. We have a green wire with a white stripe. That's going to the original fuel pump relay. That wire, of course, we're not using the original fuel pump relay since we have one with our new harness, and so it can just be cut off. We're going to deal with a fuel relay in a few minutes. The orange wire coming out of here is going to a common power wire. Once again, this isn't needed because we don't need that power going to the original ECM since we've eliminated it. We have another wire which is I call this baby blue in color, and this is the air conditioner request wire. It's the one that tells the ECM on the stock bureau if the ECM, if there's an error, a fuel error or any other kind of error in the ECM, it doesn't allow the air conditioner to be run, kind of like a limp home mode. You know, if you have a check engine light, your air conditioning doesn't run, and that's what this wire originally did. And we'll be eliminating this wire from the original ECM because we don't need that. We have another wire that will compensate for that when we get to that point. Then we have these three wires that are going to this other plug. They'll be cut off of here, and we'll deal with those when we talk about the other plug. And then we have two wires going over to the ALDL plug, which is being eliminated since the new ECM has an ALDL wire, and we'll be cutting these off of here, and we'll be eliminating this piece from our harness. We actually don't even have to cut off these two wires because the ALDL is being eliminated anyway. We can take it all out in one piece. Okay, we'll show you some more in a minute. Okay, right now we're dealing with the ALDL plug. This gets eliminated. The wires coming out of it really have no function with the new ECM. The black wire with a white stripe is a common ground. The tan wire with a white stripe is going to a common connector that deals with fuel pressure. We've got our own fuel pressure regulator we're going to be using, as you know, so we won't be needing that. And the green wire is going to be eliminated. It has to do with the cruise control. It tells the you know, it's a cruise control pickup for this thing, and it goes all the way back to this bulkhead plug, or this plug that's over on the right side inner wheel well, the plug here. It goes all the way back to here, and we'll be taking that out. So we'll be totally eliminating the ALDL plug. The new ECM has its own ALDL plug-in, so not to worry. Okay. What we're looking at now is this plug here. As you can see, there's not very many wires left. And this plug we are keeping. Most of the leads off of it are going to be used. I'll talk about a couple of them. This lead here is for the fuel pump. It's one of the wires that's going to help operate the fuel pump. Even though the new ECM controls the fuel pump, we're going to be hooking into some of the original wiring for the fuel pump. You know, this plug is a plug that's underneath the ECM. It's actually a double plug, and it plugs into two black receivers, and they go up towards the dashboard. And we have this orange wire coming down, which is part of the original fuel pump relay, and it'll be getting cut off because we have a new relay we're going to be using. These two wires are going off to the air conditioning relay, and we'll be keeping these. This wire is the one that's feeding the fuel pump, is the power going to the fuel pump to turn it on. This wire will be left intact up through here. This little stub that's been cut off here, that'll come off, but this wire will still be going into the terminal up on this plug here. The orange wire is going to be eliminated because this whole plug's being eliminated. We don't need it. And then there's already 2 wires that's been eliminated before to take this plug out of the circuit. So very little of this we're keeping, but mostly this one wire here that's for the fuel pump. It connects it into the system. Okay, the last plug we got to deal with in this harness is this one here. These 2 wires were wires we previously eliminated. We didn't actually cut them off all the way because we're going to take the plugs out, take it right out of this plug. This wire is a common ground, although there's nothing to be in common with anymore. There's only one ground left, and it's going to that ground eyelet that we showed earlier, right here. So we're going to keep that ground. These 2 pink wires, one of them's got a white stripe and the other one's pink all the way. They're 12 volts coming from the instrument panel, coming from the fuse panel up front, headed towards the engine compartment. And I'm leaving those in there for right now. We'll be taking them out on our car, but if you've got anything in the engine compartment that you want to power with a 12-volt wire, you may want to consider these. These actually connect to the 2 fuses, the second row over and the number 2 and number 3 down, the fuel pump or fuel injection fuses that are in the fuse box. So if you want some fuse power in the engine compartment, you could use these for that, provided the amp draw isn't so high. This one tan wire is the wire that operates the gauge. It's the one coming from the oil pressure sending unit to operate the fuel gauge. These 2 wires here are going to the fuel VSS sensor. We talked about that earlier and said we were saving it. And these 2 wires going up are going to the air conditioning relay. This wire, we're keeping it, and we'll be using this along the way, and that pretty much eliminates them all. And this wire, brown with a white stripe, is the check engine light wire. It'll be connecting into the new harness. And these 2 wires here are a pink with a black stripe and a black wire. They're being eliminated from this plug. They're not needed anymore. And that's it. There won't be much of this harness left, but this is all you get. Okay, to finalize our plan on this harness, as you can see, there's not much left, but what's left is what we need. We have this dark blue wire that's going up to the air conditioning relay. That's going to be going to ground to operate the air conditioner. Over here on this plug, this is for the fuel pump. It's going to go to the fuel pump and help us make our connections with the fuel pump. This wire here is a brown with a white stripe, and it's going to be our check engine light. It'll hook into the other harness. And then over here in this half of the harness, we have the pink wire and the white wire. Of course, the pink wire is the one that used to go to your ignition on your fuel. That's the wire that's hot when the key is in the on and the start position, and the white wire is your tack wire. Everything else still has connectors on and is still going to plug in where it started out at. And, you know, just for example, the alternator wires and the plug on the back end of the AC air conditioning compressor. And these wires are all going to be going to where they originally went to. You know, here's the other air conditioning wires. So we only have like 5 bare wires in this. These other wires are optional that, remember we talked about, you got a couple of wires here in case you want some power in the engine compartment. You know, 12 volt, low amp. And that's it. We're going to start wiring the car by taking the aftermarket harness and putting it on the engine, and then we'll be integrating this harness as we go. And to finalize that part of wiring harness, if you don't have this many wires laying on the floor when you're done, you didn't do it right. Okay, we've hung the harness, the new harness for the LSx V on the board here, just to briefly explain a few things to you, or show you a few things. These two plugs and this third plug, they plug into the ECM. That's pretty self-explanatory. Most of these wires in this little bundle are for the cruise control. The cruise control is something new that I've had them add to the harness. We've done it one time before, and but we're going to actually get the car running before we hook up anything on the cruise control. We'll cover these wires as we go. There's also one here for the check engine light. All these tags that are on here are put on with the harness, and you want to be careful not to take the tags off till you get the wires figured out where you're going with them. Anyway, there's a check engine light there, and there's a tachometer light wire there, and then most everything else is dealing with the cruise control. Okay, and then we have the ALDL plug. That's pretty self-explanatory. We have, this is the fuel pump relay. Remember it said we had a hot feed for the fuel pump that will operate the fuel pump off the new ECM, and this is the wire that's going to be connecting to that one on the other harness. These wires coming off to the side are for a couple of features that aren't used, so they'll be eliminated from the harness. And then coming down here, we have the fuse block, and we have two wires leading to the fuse block. One of them is hot with the key on and hot with the key in the start position. Remember the pink wire from the original harness, it'll be hooking up to here. And then the other one is the battery wire. In other words, it powers the ECM all the time. And this one is going to be going down and connecting to the large terminal on the starter, where the battery feed connects to the starter. And we'll show you that when we get to it too. Okay, we moved the harness up here so it's a little easier to get to some of these. But each one of these wires assemblies coming out of here is labeled. For example, this is a passenger side O2 sensor. These are injector wires. This is the passenger side coil plug. This is the crank position sensor. A couple more injector wires. The mass airflow MAP sensor, the throttle body connector, and the mass airflow sensor. Looking down through here, I'm not going to cover every one of them because most of them are labeled, but this is the oil pressure sensor. This is the one that deals with the oil pressure for the ECM, the information for the ECM. It does everything except the gauge. Unwind a couple of these. It looks like a lot of wires, but all these wires all plug in. This one here is for the electric gas pedal, so it's going to stay up underneath the dash, and it'll be routed up towards underneath the dash, and it'll connect to the gas pedal. Again, we have injector wires. That's these groups of wires down through here, and the driver's side coil wires. These are the injector wires for the driver's side of the engine, and this is the coil plug for the right side of the engine. That's all the way down through here. We get down towards the bottom of this hunk. We have a coolant temperature sensor, which is in the cylinder head. We have a reverse lockout. Now this wire is one of the ones that will be eliminated because we're not using an automatic transmission, so we don't even need this one. And then we have a cam position sensor. We also down here in this group here, we have an alternator wire. We'll be wiring this into our alternator wires, and we'll be showing you how that works. This one here is the driver's side O2 sensor, and there's actually an O2 sensor plugged into it right now. This wire is a skip shift sensor. Again, this is not an automatic car, so we won't be using this. Remember the green and the red wires I talked about in the last little segment. The red wire runs to this one, and that other plug that I said we're not going to use has the green wire running to it. And then this is a brake light switch, and I already did the cam sensor, but these will all just be plugging into the engine, and then we'll integrate this into the Furo harness right there on the engine. So it's going to be pretty simple when we get right down to it. It's just one wire at a time. All these plugs plug in a certain place. None of these plugs are universal fit. In other words, all the injector wires, those are universals, but the lengths dictate which injector you're plugging them into. It's going to be real easy to figure out which one to plug them into. Like the crank position sensor, It's a special style plug. There's no other plug that'll plug into that sensor. You know, there's no two plugs on here that are the same except for the injector plugs and the injector coil plugs, but those I think are a little bit different. But you can't get them wrong because they go on the left and the right sides of the engine. And that's it. We're going to start putting this harness on the engine. We'll try to leave the labels on so that you can follow along. Okay, we're starting to put the harness in the car. We've stuck enough of the harness with the plugs through the hole here to be able to reach down to where the ECM will be. And then took some of the shrink wrap off the outside of the harness because you have different things that have to cut off in different places. We have a fuel pump relay that cuts off here, and it doesn't normally cut off here, so we have to make a cut off here so it can come over and mount basically where the stock one was. So you'll have to split the harness open and take the items off of it where you need them. For example, the oil pressure sending unit wire needs to come off so that it comes over here towards the oil pressure sending unit, that kind of stuff. And then the engine, even though we turn the intake manifold around, in this view, the left side of the engine is still the driver's side. So the wiring harness plug-ins and stuff that were designated for the driver's side, we've run in along here and plugged in the injectors and plugged in the coil plug right here and the injector wires. And then we took the other half of the harness that goes on the passenger side, and we did the same thing, took it along the passenger side. And we've got O2 sensor wires and speedo sensor wires and the knock sensor wires and stuff going down on this side, and we had, you know, these had to be rerouted slightly, you know, branched off is what I'm really saying, branched off to places where we want them to go, and then like this ground wire is going to attach here to the cylinder head, along with a couple other ground wires at some point. And the ground wire was a little bit too long, so it's been looped up around and then back down to come out right here. Okay, we've been working on the wiring harness, and we're going to try to bring you up to speed on it and show you what we've been working with. We took the Fiero part of the wiring harness, the part that we had hanging on a board in there, and we plugged it back into here with the other junction block here that goes back towards the tail lights. And we also, that one orange wire with the flat connector had two holes in it. We hooked it up to these two studs right where it came from originally. And we also reconnected this orange fusible link to that same connector, and we tightened up those two screws. And with the Fiero harness, of course, we have a few wires coming out from the Fiero, you know, from the junction block that are part of Fiero harness, and they're coming out this direction. Several of the wires, like the wires that go down to the alternator, the wires that go to the air conditioning, and the purple wire that goes down for the starter solenoid, that we're dropping those down along the bulkhead. Can't reach down in there, but you can see where they're disappearing, and they're going down towards the alternator, the starter, and the AC compressor area, and they'll be hooked up underneath. And the rest of the wires from the junction block here, we've already got them covered with intestines, and they're running along the top of the valve cover over to the other side of the engine because they're required over there. But for right now, I'm staying over here on this side of the engine. The wires for the water temperature sensor are right here. They're still a little bit long yet. They'll be trimmed back a little bit, and they'll be going to that sensor that we have mounted underneath the thermostat housing block. Okay, one of the other wires that branches off from this Fiero harness here is this green wire, and it goes to a ground. This is one of the grounds from our video when we had the wiring harness hanging from the wall. And this wire is quite long right now, and we'll be shortening it up, and and running it to ground right down here on the engine from at this end of the engine, instead of running it to the other end of the engine and grounding it. Another wire that you see in this that we have taped to this harness right now, it's a wire coming from inside. It's a 14 gauge wire that we're running over for the fuel for the water pump, and it's coming through from the interior. It's going to be coming from the gauge or from the fuse panel up front, and it's coming through this wiring harness here, and it's being routed around along the valve cover, and then it's coming out right here, and it's going to go over to this plug. It's going to go to the blue wire on this plug, which is the hot wire for the electric water pump. We put in a heavier gauge wire rather than using one of those pink wires we saw before, because this takes higher amperage than those wires are really rated for. So we use a heavier gauge wire, and we're going to bring that over and hook it here. And then this black wire will be going to ground, of course, for the water pump. And the electric water pump, of course, is right here. You've seen it before. Okay, we have our fuse box mounted up over here, the fuse box that comes with the aftermarket wiring harness. And then the wires are going down into here. And we've got a couple of relays down here. The one on our left is the one from the original Furo AC relay for the air conditioning. And then the other one that we have bolted on here is the fuel pump relay that operates the fuel pump through the new wiring harness. This fuel pump relay and of course the wiring going to it came with the wiring harness. Off of this air conditioning relay, there's a blue wire, and we have the blue wire routed down along here and up through this harness here, and it's going to go to a ground. Right now, the wire is just hanging loose here. It's a dark blue wire. Remember, we talked about that one. And this wire will be going to ground. So your air conditioning will operate when you push the button inside. Okay, and we have another wire we're working with here. You'll see the green wire with the white stripe. That's the wire that runs down to the air conditioning compressor, and it operates the fan when the air conditioning compressor is turned on. Right inside that intestine wire cover there, we have another wire spliced into this wire. Remember, we had two plugs that were on the green wire with the white stripe before. One of them went to a sensor on the engine block that turned on the radiator fan when the engine got to a certain temperature, and the other plug went to the AC compressor. The AC compressor plug is still there. We instead of using the other plug here, we're running a green wire down through this intestine that's running along the valve cover, valve cover here. It's coming all the way down here, and then it'll go down. It goes down into this harness, and right now it comes out here. I've got it pulled out of here just a little bit for you, and it runs inside to the interior, and it'll connect to a certain terminal on the wiring harness for the ECM, the new ECM, and that wire will run the radiator fan when the ECM reaches a certain temperature that's programmed into the ECM, and that'll turn on and turn off the radiator fan for us. Some of the wires from the original Furo harness that we kept are the two wires for the backup light switch, and we ran those along the top of that valve cover again, or alongside that valve cover again, and brought them over to this side of the engine. And we have those plugged into the plug on the transmission that operates the backup lights. So the backup lights come on when you put it in reverse. We also have these two wires here. We talked about these before. These are the wires from the original Furo wiring harness that go to the VSS unit on the transmission. Right now, they go through via this plug right here. Right now, the wires are too long. They have to be shortened up a little bit. The wires are like 6 feet longer than we need, and but they'll be shortened up, and then that plug will plug into here, And then we have two wires, a purple wire and a yellow wire from the new wiring harness for the LS3. And these two wires will be spliced directly into the purple and yellow wires from the original VSS. So the yellow wire from the other ECM will be teed right in right here, and the purple wire from the new ECM will be tied in with this purple and white wire right here, and that'll give us a VSS signal so that for the computer, that'll give us a VSS signal for the computer. The handy part about that is when you come to a real quick stop, push in the clutch and come to a stop in a hurry, a throttle body doesn't really have an idle stop, and it's controlled by the VSS. And the VSS it tells the computer that even though you pushed in the clutch real quick, you're still moving and you still need the idle. And what it does is it brings your idle down when you let off the gas, it brings the idle down slowly so it doesn't go down and stall. They've been doing that on GM fuel-injected engines since about '86, and it still works. At this point, the only other wire we have to talk about is the wire that used to connect to the center terminal on the original Furel oil pressure sending unit, so that we'd remember which one it was. And that's the one that's going to operate your Furel oil pressure gauge. And of course, this lead is a lot longer than it needs to be, but we haven't hooked this up yet. But it will be going over, and I can't actually show you the connector from here. It'll be going under the throttle body, and then over in this area here. Oh, I can see it. Bring the light just a little further down. There it is. It's going to be going down to the oil pressure sending unit. It's going to be attached to this unit here. And that plug for the oil pressure sending unit is, watch my finger, is right here underneath the throttle body. Right here. So when that thing plugs in, once the wire has been shortened appropriately, and the other two wires eliminated totally, it'll be plugging in right here. We have that underneath the throttle position, or underneath the throttle body. And this wire is a brown wire. And some wiring harnesses, this wire is in the new Street and Performance harness that we're using. And in some harnesses it's gray. Some other harnesses use a gray wire, but it's a dark brown in this harness. And it comes from, remember, underneath the hinge box over here, we had the fuel pressure fuel pump relay, and this is coming from that, and it was labeled fuel pump. It was a wire that had a label on it that said fuel pump, and this is the one that powers the fuel pump when you turn the key on and when you have oil pressure. And we've run that wire through this loom down here and routed it up and put it into the interior of the car. And when we get on the inside, we'll be connecting that to that tan wire with a white stripe that we spent a lot of time talking about that was in the original Furel harness, up by those clear-colored plugs. Okay, we have two other wires that we talked about out of the original Furel harness. The pink wire here is one of the original Furel wires, and this white wire for the tach. The pink was the hot with the key on and the key in start position, and the pink was the tach wire. Those wires are coming across from the wiring harness. They're out of the original Furel wiring harness, and we have those connected to the, for example, the white Furel tach wire is connected to the white wire in the new Street and Performance harness that was identified as tach wire. And of course, that wire runs on inside the passenger compartment and is hooking up to the new ECM for your tach reading. Of course, the Furel end of that harness, the Furel end of this white wire, is going to the gauges. And then the pink wire that was coming from the Furel ignition system is connected to the pink wire that runs through this harness and over to the junction block right over here. and that pink wire is labeled hot with ignition on. So that's the wire that powers up the ECM when you turn the key on, and that's where this reddish colored wire is going to, that the pink one is connected to. That's a simple connection. And like I said, the street and performance wire said hot with ignition on and hot in start, you know, the label that was on this wire, and it's connected to for your old coil wire. You know what? Okay, that's basically what we're doing with the wiring harness. There's still a few connections and stuff to be made up here on top, and then there's connections to be made in the interior, and we'll cover those. We'll cover the ones in the interior later, and there's some connections to be made underneath the car, but for the most part that covers what we're going to be doing under the lid here. But we will come back, take a look at the finished connections and stuff when we get there. Okay, we're underneath the car working on the wiring. We have the sensor plugged in for the VSS. This plug right here is going to go to the O2 sensor when the exhaust system is back from being plated and put back on. The wire is going over here and connecting to the knock sensor. And we have the crank position sensor right here connected. Go look at the other side of the engine. Okay, we're on the forward side of the engine right now. The wires that drop down by cylinder number 1, you know, that we're dropping down along the bulkhead are right here. This is where the wires come down. The alternator hooks up just like it was before. You know, the plug up on top and the bolt-on terminal here, right here. And then the red wire from this heavy red wire comes up this harness here and goes over onto the starter, and it connects to the large terminal where the battery is going to connect. The battery cable is not on here yet, but the red wire going over to the alternator is going over to that this screw-on terminal here on the alternator, and that's what charges your battery when your alternator is running. And then on the AC compressor, we have the wires plugged into the back of the compressor. You know, the original wires plugged in right where they were before. Okay, the green wire and the black wire are plugged into the AC compressor clutch, and the green wire is one of the wires from the original harness, and it's coming from the air conditioning relay, you know, the relay for the air conditioning that we kept. Also in this wad of wires coming down from along the bulkhead is the purple wire. That's the one that goes to the starter solenoid. Sometimes this wire has to be extended. It really depends upon what model Fiero you got it off of. And the purple wire is going up here, and it's going to the spade terminal over here on the starter solenoid. That's the one that's hot when you turn the key to the start position. That cranks the starter. Okay, so we have, in this wad of wires coming down here, fastened these wires, the orange wire, the hot all-the-time wire that's powering the fuse block on the new wiring harness. The orange wire is coming down here and through this loop, and it's connecting to this terminal on the starter where the battery cable is going to connect. That'll give power to the ECM all the time. And a few seconds ago, we talked about the wires that go to the clutch switch on the air conditioning compressor. And this green wire is coming. This is the one coming from the original Fiero AC relay, and it comes down through this harness here too, and goes through this way over towards the compressor where it connects to the compressor. Right down here at the clutch. And then finally, on this side of the engine, we have the knock sensor connected. Knock sensor screwed right into the side of the block right there. And we also have a wire hanging here that for the O2 sensor. When we put the exhaust system back on, we'll be plugging in the O2 sensor. And kind of cute thing, if you bear with me, is the O2 sensor has a little clip that'll, you know, snap on the wire from the O2 sensor, and that'll snap on right through this hole here. And so we have the O2 sensor wire right here, and I'll plug it right in, it'll mount right up to there. And then while we were down here, we went ahead and connected the air conditioning lines, rotated these lines around a little bit and connected them to the original Fiero lines that we talked about some time ago. We're getting ready to install the coil covers. They're a decorative item that fits over the coils and the top of the valve covers and part of the intake. They cover the coils and the injectors and all the wiring and connections underneath them. The cover that's towards me here is the one that's going to go towards the rear of the car. It has the opening for the oil fill cap, and the one on the other side has the opening for the fuel line coming in. Now these will have to be trimmed a little bit, and you got to put these on to trim them. You got to start fitting them on there and trimming them, and basically what you end up with is a bit of a cut over here on this end, cutting off this end of it to clear your shock tower. And then on the other one over here, you end up cutting a little bit right up in here to clear the hinge box. And we'll fit these onto the car. I'll show you what they look like when they're on there. When these covers go on, they clip on. These clips right here go over the fuel rail, and then down here at the bottom there's a couple of holes in the valve cover that you can put some little bolts in there and grind off the head to make a little pop on things. You can't buy those pieces separately. You have to make your own. Tell you the truth, you don't really need them because these covers aren't going anywhere. Once they're on there, you'll see that they're not about to go anywhere. Okay, here's the coil covers on the engine. You can see there was a little cut made along right in here to clear the shock tower. On an 84 through 87 car, it'll be a little bit different cut. And then it's just on there right now. See, it's not really going anywhere. It's clipped down over the fuel rail and the back end of it. Step around here on the side. And this, the end on this side is pretty secure, even though that we don't have clips down there in the bottom. And then, of course, there's a little notch here for the dipstick, but the notch was in there, in the covers when you get them. And then on this side, you have a little cutout here on the cover to clear the hinge box. And then the fuel line is a clip-on type fuel line. That's why we use these fuel lines, so it'll just clip right on there where it's supposed to be. No modification or anything over there. And they make it look a lot better. They make it look pretty. This is a screw. It's a 6mm Allen head cap screw, and it's about 1.5 inches long. Has about a 1/2 inch of non-threaded shaft up under the head. Those little clips that are used to clip down the coil covers, the coil injector covers, the little pins that it clips down over, you can't buy them. There's no GM part number listed, so we make them, and this is what we use when we start making them, and I'll show you what they look like when we're done making them. Okay, here's that little cap screw that we made for the clips for to hold down for the injector covers. We took that cap screw that you saw and ground it down to make it a little pointy and still keep the hex for the Allen wrench in it. And then we use a little jam nut, and we also shorten the screw up a little bit. And we use a jam nut to get these the right height, you know, so we can adjust the height of the coil covers so that they look good. When we put these in, then we'll just use the jam nut to jam them in place once we get them adjusted to put where we like them. Okay, we're working on the cold air intake for the LS3 car, and you have to have the LS3 uses LS3 and LS7, LS376, and some of the LS2s use a mass airflow sensor. Looks like this. It's they call it a credit card mass airflow sensor because it's small. And when you mount this into the cold air intake, you got to have a flange. This you can buy from GM, and it usually comes with a lot of the crate engines, depending on where you get your crate engine and stuff. But it's a fitting that'll fit into the cold air intake. It'll fit on the side of the cold air intake, and then this thing here this mass airflow sensor slides inside of it. We're putting 4-inch cold air system on the car, and that's really what's called out for with the LS3 and most of the bigger LS engines is a 4-inch intake. So that's what we have here is some Spectre Performance 4-inch cold air intake. But we have to mount this piece into it and then mount it in the correct direction, and then the mass airflow sensor will go into it. Here we have the mounting flange mounted into the cold air intake. It's got to fasten on. There's 4 holes here that it fastens on with, and we get those holes pretty precisely drilled. Then we put really tight-fitting pop rivets in, and then the air intake comes from the right on this, because when the mass airflow sensor goes into there, it only fits in one way. There it is. It only fits in one way. If you try to put it in backwards, it won't go in there, or at least the holes for fastening it down won't fit properly. And the mass airflow sensor, if you look at the face, this black face right here, there's a little arrow right here, right where my thumb is. There's a little arrow that says what the direction the flow is, and so it goes in like that. And we're going to put it into the cold air system, and then we're going to go take a look at all that. Okay, we're working on the cold air intake. Just showed you all about the mass airflow sensor, which is over here on this side. We kind of hide it, make it look, as good as we can. We're using Spectre Performance 4-inch diameter cold air intake parts. We've got a Spectre style clamp that's clamping each section together. We have a 45-degree angle here, and then a 45-degree angle here going down, and then a 22-degree angle right here that shoots out through this hole in the inner wheel well sheet metal. We did have to get that 4-inch pipe to go through this hole, you do have to bend the flange down on the bottom. The flange right at the top of the frame rail, it needs to be flattened out just a little bit. I took a couple still pictures of that, and I'm going to put them into the video right here at the end of this segment. And then over here in the wheel well section, we use a piece of straight-inch 4-inch tube, and then we use a can-end filter, and that's how it all comes out. And then, of course, this filter is located just adjacent to the intake that's on the bodywork on the driver's side of the Fiero, and that's where you're getting your air from. In addition, you're also getting your cold air in from underneath, because when the wheel well liner is in, it's still open from underneath, so you're getting cold air in through this opening end from in front of the wheel well liner. Here's a picture of the cold air intake in the front of the wheel well. We'll have a wheel well liner, of course, will be covering this side of it, but it's still going to be open from below, and they'll be able to draw air from below and some air through this side thing. And you see how this lip is bent down right in here to clear this 4-inch tube, and now the gas tube is just above it. Okay, we're inside. We're messing around with the wires inside. We're going to do this just a little at a time here. These three wires right here, the blue wire, the green wire, and the brown wire, are wires we ran in from the other side, from the engine compartment. We ran through the bulkhead, and we talked about these when we brought them in. I'm going to talk about them a little bit more now. The green wire, it's going to come in and it's going to connect up to the wire from the ECM that's labeled for a cooling fan. This is going to turn on the radiator fan when the engine reaches a certain temperature and shut it off when it cools down. And this label, if you can read it, says cooling clutch fan control. And the green wire will connect to that. The colors of the wire for the fan switch from the ECM are going to vary depending on whose wiring harness and stuff you're using. So we're not even going to deal with the color. That's what the wire is labeled, and that's where we hook it up. All right, so this blue wire can go up to the fuse box, and it connects to one of those two fuses for fuel injection that we talked about earlier. But you'll want a heavier wire coming back this way, so this heavier wire will go all the way up there, and we'll just do a little surgery on the back side of the fuse box to up the wire size on the fuse box. Okay, so this one is the brown wire. It's coming from the fuel pump relay, and it's going to go and attach to the gray wire, or the tan wire with a white stripe that goes into this 4-prong plug. That's the one that runs the fuel pump, the in-tank fuel pump. It will run off the new ECM. So where I have these here knotted together, they're going to connect to each other, and of course, real nice and neat. Now on this clear colored plug, it plugs in those plastic plugs that are in the wiring harness, those two black plastic plugs that we left in the wiring harness. There were several wires that we disconnected from those plugs, and in this plug, receiving plug here, we took out the brass terminals in there for those connecting wires. No need to have them in there, so we popped those out. So there's less wires in this plug now than there was before. We just eliminated the ones we don't need to be using. Okay, we have another wire here, a brown wire, and this wire is coming from the new ECM, and it's a check engine light wire, and it's going to connect to this white plug also, and it's going to connect to this brown wire with a white stripe. It's a real dark brown with a white stripe, and that's going to allow you to go up and operate. It's going to be using the stock Furo check engine light with the new ECM. So this is the brown wire with a white stripe from the Furo harness. We did talk about it when it was hanging on the wall in there. And the check engine light wire will connect to it, the check engine light wire from the new ECM. Okay, this group of wires is a group you haven't seen yet, but it's in here hanging from the new harness. It's part of the new harness that goes inside the passenger compartment. And these are all wires that are for the cruise control and the speedo, the 4K pulse for the speedo and stuff. And these wires are coming out of the new ECM wiring harness, right where it plugs into the ECM. These wires are all going to be extended up and up under the dash in the dash area, and we're going to explain how these are all hooked up as we do them. So they're all going to be running up through the console. And for the most part, that pretty much covers where we're at right now. We'll be making those wire connections we just talked about, and then those two plastic plugs plug back into these two black plastic receiving plugs when we're all ready to go, and it'll tidy it all up. Okay, I didn't mention before that we mounted the ECM up to the bulkhead. It's easy enough. There's places you can put screws through it and bolt it in. Now we've got the wiring all cleaned up back here, and we've taken the leather seats are squeaking. Got these plugs put back together. We took the blue wire that's coming from the water pump, and we actually ran it through this little plug-in and one of the extra plugs we had, or one of the vacated plug holes, we ran it through this plug, so if you ever have to unplug it, you can unplug that wire too. And it's going up under the console, headed up towards the front. And it'll go up under the dash and hooked up to a fuse for the electric water pump. All the other wires that we talked about are in the harness and put in and connected and covered with some black electrical tape, make it nice and neat. And pretty soon we'll be putting the console back in the center console cover and proceeding. There's a nice view through the sunroof. Okay, in this view you can see our wires for our electronic throttle pedal are coming right up here in the area where the cables used to come through, and they just come up and plug right into the pedal unit. And you can also see up here we have our blue wire that runs up under the console that goes for the electric water pump, and that's been routed up here and headed over towards the fuse box, and we're mounting that, taking that into the fuse box and mounting it in one of those two fuel injection fuses. Of course, we're going to up the amperage on the fuel injection fuse. Okay, over here on the fuse box we have our blue wire, and we pulled one of the wires out from the fuel injection fuse, and we're going to take this clip off the end of it and put our heavier blue wire on, the one for electric water pump, and we'll put it onto this clip, and then we'll slide the clip back in there. The fuse that of course we're going to up the fuse size. Whoop. And the two fuel injection fuses that we've been talking about all this time are the second one over, second one, and third one down in this view. And we're using, of course, the second one over and second one down is where our blue wire is going to be connecting to, and we'll be putting a 20 amp fuse in there instead of the 5 that it originally had, and that'll be the water pump fuse. Okay, when you're doing an LS swap to a Fiero, you do have to put a little bit of a signal booster on the signal from the LS engine. The tach signal is a real weak signal, and so you have to boost it a little bit. And we're here to show you what we do to get that done. We go to Radio Shack and buy one of these metal oxide resistors. This is a 1 ohm. 1 watt, and it says plus or minus 5% tolerance. And these only cost $1 or a couple dollars each. Anyway, we take that resistor out of there, and then on back of the tachometer, now we also do our V8 conversion to the tachometer, which is right here, and I'll be happy to send you instructions for it, but that's not what I'm here to instruct you on. We have instructions for this, plus we do these tach conversions as far as this. Converting it to a V8, we do these in-house, and we also can send you the instructions. You can do it yourself. But on the back side, we also have to strengthen the signal for the output of the tach on the tach sender unit on the LS engines isn't really strong enough to operate a gauge. So what we've taken is one of these little resistors, like so. And the resistor is now inside a shrink wrap. It's already been shrink wrapped, but it's soldered on over here on this end. It's soldered on to the 12 volt lead. If you follow this circuit back, it goes to this 12 volt lead, which means you got 12 volts at this end. Over here on this end, it's connected to the terminal that goes to the coil terminal on the back of the tach. So it's feeding 12 volts through that resistor and over here to this feed to boost the signal, boost the tach signal. Simple as that. Like I said, the tach conversion is something that I can send you instructions for, but when you put this tach back in, you have to have the tach conversion done, plus putting in that resistor on an LS series engine. And this potentiometer right here, this is just a potentiometer right here, and it's soldered in. Typically on a 4-cylinder or 6-cylinder Fiero, the resistance for the tachometer is across the back of the chip. That's this Whoa! Watch out. That's this area right here, this dark area, you know, this shiny black area there when going across the back of the chip. And this potentiometer is just put in there to replace that off the back of the chip. So you're generating your resistance through the potentiometer, and you adjust the potentiometer to dial in the tachometer when you first get, like Rob just finished doing on this one. He's got the tachometer ready to go back in the car, and he hooks up the leads on the back. He hooks up a ground, he hooks up 12 volts, and he hooks up a coil lead, and then runs the engine, and he has a tune-up tack, or actually we have a scanner attached to it. We can tell what the engine RPM is, and then we just adjust with this potentiometer that's right around here. We just adjust the tack so it reads the same as what the scanner reads. There we go. Okay, we're in the car, and this is the center console. We're right behind the shifter here. And we have the 5 wires coming from the cruise, and they're all hooked up already, but I'm going to try to explain to you where each of them's going. And I'm going to do this in little segments so that I can show you up under the dash and up here too. Okay, here we have 2 of them. One of them is labeled brake light cruise release, and the other one is labeled cruise CHMSL. These 2 wires are both going to be going to the same place, so we haven't put covers over these or anything, but we have them both soldered together, and they're going up to the pedal, and they're going to attach where the white wire is attached on the pedal, on the brake pedal at terminal A. Okay, this wire is a gray wire, and it says cruise resume, and it's headed up towards the front. I'm going to show you where it goes. Okay, you can see the white wire here that's just underneath the orange one. That's terminal A on the brake pedal switch. That's where those wires are going. Okay, we're up underneath the steering column, and we've got this little plug here. And it's the original plug from the car, and it's got 4 wires going into the back end of it. Originally, those 4 wires went over to the cruise control unit that's behind the carpeting, this plug that plugs into that cruise control unit. We're not using that cruise control unit anymore, so we went ahead and cut those wires off here and brought them up to connect to our wires that are in our console area. So what that means is this gray wire here with the black stripe, which is just above the blue one in this view. That wire is the gray wire I was just showing you in the console that's labeled cruise resume. We just brought that wire over here. The wire was already here. We just cut it off in the plug and hooked it up to our cruise wire from our aftermarket harness. Okay, back up here on the console we have 2 more wires. We have a light blue wire, and we have a blue wire, darker blue wire with a red stripe. That would be this one here. And those are going to go make connections for us. These are coming from the new ECM for the LSx V. Out of these 2 wires, the light blue wire is for the set switch. It's going to be the set button on your cruise control stalk for setting your cruise control, and then the blue wire with the red stripe, that one is the on-off wire. Okay, coming back over here to this plug from the original harness, the blue wire that was in the console, the light blue wire, is the set wire, and it's going to the gray wire that's going into here. We just took the gray wire where we cut it off over by the plug and just brought it up to made up with the wire we were just looking at. The blue wire with the red stripe is going to the blue wire. The blue wire from that we cut off from that original plug is splicing into the blue wire with the red stripe. I'm also including with the written instructions that come with this kit the wiring diagrams for these connections in case you want to double check them, or in case your Fiero is wired a little bit different. This is an 88 Fiero GT. Some other Fieros may be wired just a little bit different depending on what plugs and what options they had on them. Now this wire and plug deal that used to plug into the cruise control unit on the original Fiero cruise control setup, you know, that unit that's down here behind this placard, or this carpet, these are all just extra wires. You don't need them for anything. You can take them out, or just don't plug the thing back in because it isn't going to do any good anyway. There's no ECM to control it. Okay, we got our exhaust system back from ceramic coating, and we're about ready to put it on. As you can see, it turned out pretty decent. And we did the mufflers too. The tips are sitting over here. Still got to do a little polishing on them. Okay, here we have the ceramic coated exhaust system attached to the car, back on the car. This may be one of the last views you see from underneath the car. Right now we don't have the clamps on. We have some special clamps ordered, some strap type clamps that won't bend the pipe. Those will be in tomorrow. So the exhaust is drooping just a little bit here, but we'll have those clamped up tomorrow. And take an underneath look, probably for the last time. You can see the muffler here. We had the mufflers HTP coated too. And it's hard to see up there, but the floor of the trunk is about 2.5 inches above the muffler. Little tour, last tour I think. Okay, as we've said through this video, we've with the electronic throttle body on the engine, you have to do a little special setup for the cruise control. And we had the cruise control wires built into the wiring harness, and we'll show you those hooked up under the dash here pretty quick. However, we changed the outboard CV joint on the axle to one with a reluctor ring on it. And I don't really know what the application for the outboard CV joint is, but it slides right onto the axle. It's probably from an automatic car, but it slides right onto the axle. It has a correct spline because it has the same shaft diameter as the stick shift Fiero axles. But you can see the reluctor ring here. We bought this, the axle shaft we stole this outboard CV joint from. We got from our local CarQuest store, and it was part number RDS 5812. According to receipt, the number has changed, has been superseded by RDS 410382. But that would be this outboard CV joint with the reluctor ring. and we're using a magnetic pickup that we had around. The particular one we're using is from a transmission, and but just about any magnetic pickup, and then we're custom making a bracket that's going to bolt the pickup on out here on the left CV joint or left spindle assembly, and we'll get our signal for the cruise control from here. Here's another shot of that outboard CV joint with the reluctor ring on it that we're using, and then we've made a mount to mount the magnetic pickup to, and we drilled a couple of holes in the back of this and threaded them for our fasteners for holding a new bracket on that's holding the sensor for reluctor ring into. Okay, this is the bracket we made for the sensor for the reluctor ring, and these two holes you see right here, these are the two that are going to go into the spindle where we drilled and tapped some holes, and then the reluctor or the sensor will go in through the big hole and attach through the small hole there. We'll put that together and show it to you again. With the sensor attached, looks like this. You can use just about any type of magnetic sensor. This bracket and the sensor are not included with the LS kits because the kits aren't necessarily for the electronic throttle bodies. You know, if you have electronic throttle body, it's an upgrade to you have to do if you're going to do cruise control. Manual throttle bodies use a stock real cruise control setup. Anyway, you can see that this is bolted on here. This is actually a sensor that came out of a transmission. It was a gear sensor for a transmission. These electronic sensors are just about everywhere. You can make any of them fit your bracket. Make yourself a bracket to fit the sensor you have. Okay, here's a picture of the sensor mounted up, and we'll be hooking up to two speedo wires from the wiring harness from the aftermarket LS wiring harness to the sensor on this, and that should give us a proper signal for operating a cruise control. Okay, in videotaping the assembly of the red car that's subject to this video, we failed to show you the bleeding procedure for the cooling system. So we've got the black car here, the LS 376 car, and we're going to kind of cover it here. The first thing to do when you go to bleed the cooling system is to remove the hose from this gooseneck. That would be this hose right here. And we'll start filling the cooling system by putting water in through the hose with the radiator cap off. We have the back of the car jacked up in the air about 8 or 9 inches, and we're going to put water in through this hose, and then as we put water in through the hose, the cap is off, the radiator cap is off, and the water will start, or the air will start bubbling out of there, and when you get a good flow of water through there, put the radiator cap back on while you're still putting water in through this hose, and then you'll come back here in the back and water will start coming out the gooseneck. As we're putting water in through the gooseneck, through the hose here that's attached to the gooseneck, this line right here is bringing water, is letting air bubbles and stuff out of the engine because it's going in above the thermostat into this gooseneck, and this will be bleeding your air out of your system. Most of your air will be coming through here. Okay, at some point during the bleeding process, sometimes you're not quite feeling like you're getting all the air out. Sometimes you have to pull this hose off from the electric water pump,
and it'll let some of the air out. You'll hear a rush of air when you pull that hose off, trying to get the water through the cooling system. When we're bleeding the cooling system, we typically take a piece of half-inch exhaust pipe and put a 90 in it, and actually even flared out the end of it and make it a little bit easier. But when we're pumping water into the system, we're pumping it through the hose, putting it in through this pipe, and then it goes down through the hose, and it's pushing the air out through the engine. This is going into the radiator. This water will be flowing towards the radiator, and it'll be coming back towards the water pump, and then from the water pump into the engine block, and pushing the air out of the engine block. Also, when we're putting antifreeze in, which is where we're at on this car, we're just about ready to put the antifreeze in. This is where we're putting the antifreeze in, and then as we're putting the antifreeze in, water will come dribbling out of the gooseneck, and it'll, the antifreeze will displace the water, so you're not wasting any. You always can pull off one of these hoses right here if you want it to go a little bit faster. You can pull off one of these hoses that goes into the thermostat housing block, and that'll increase your flow a bit. Well, actually quite a bit, because otherwise your air is just coming out through this little tube here. If you had pulled off this hose, you can increase your flow. You can do that also while you're filling the cooling system with water. By pulling this hose off, it'll increase your, make it go faster. At the end of your filling the cooling system with water, you'll have to put this hose back on. The idea is to try to get all the air out and systematically get all the air to come out through this gooseneck or through this hose going into the thermostat housing block. And that's basically it. We're getting ready to put antifreeze in this, so that's why we've got it apart for right now. Once you get your cooling system set up, before you put your antifreeze in, then hook all your hoses back up and run the engine for a little bit. Keep an eye on your scanner and your water temperature, and make sure the water is flowing through the pipes by feeling the upper and lower radiator hoses up front and the heater hoses, and that gives you a clue as to if you're doing a good job or not, if you're getting your cooling system filled. And sometimes you got to come back and burp this after you've filled the cooling system and got the engine good and warm. Let her cool down and burp it again, and it won't hurt you a bit. Let me show you up front a little bit. Like I said, when you're initially filling the cooling system, you'll have the radiator cap off. You also want to make sure your reservoir has water in it, because when you test fire your engine the first time, any air that's in the system is going to get displaced by the water that's in your reservoir tank. And then your heater hoses on your heater core are these two hoses right here. And when you're testing for your flow, first place you're going to notice flow is one hose will start getting warmer than the other one. The heater core flows water through the heater core whether the thermostat's open or not. So this is the first place to tell if you have flow. Okay, now Rob's putting the antifreeze in, and not spilling a lot of it. And this hose right now is off just to make things go a little bit faster. You see there's water coming out of this hose, and it's displacing, the antifreeze is displacing water. Okay, that's about the story. As he gets the other gallon of antifreeze in, he'll put this hose back on, this one back on, and once he gets the other gallon of antifreeze in, this pipe will come out of here. This thing will get shoved back onto the thermostat as quickly as we can and clamp down, and time to start driving.
turn left here. Go out to the stop sign and turn right.